তুমি শুনতে পাচ্ছ? ফোনে করে কথা বলছো না? হ্যাঁ, এটা চ্যাটে দিয়ে রাখবো। দিয়ে দেবো সেটা। মিউটিতে আছে। কোনটা কোনটা ডেস্কটপটা? ইনসে আমার ইয়ে করা যাচ্ছে, মিউট নেই। এটা কি বলছে? হার্স কুত্তা এক্সটার্নাল ওয়েটিং ফর তাহলে আমারটা শোনো না, আমি আমারটা এরমভাবেই রেখে দেবো তো, টিমসটা খুলে না ওবিএসটা খুলে রাখবো? মিউট করা যাচ্ছে। আচ্ছা, স্ক্রিন শেয়ারটা তাহলে যে করবে সে এখানে জয়েন করে তুমি যদি স্ক্রিন শেয়ার করো আমি দেখতে পাবো তো?
সেকেন্ড বেঞ্চে চলে যাই। না না, ফার্স্ট বেঞ্চ করছি।
আচ্ছা,
কলেজ তো মানে আপনার সেই সফিস্টিকেশনটা এক্সপেক্ট করা যাবে না। বুঝলেন? ক্যামেরা থেকে সোর্স ক্যামেরা থেকে সোর্স দেবো। হ্যাঁ, আমাকে দাও, আমাদের গ্রুপে দাও, আমাদের গ্রুপটায় দাও, অফিসিয়াল গ্রুপটায় দাও, টেস্ট করে
বলছি হয়ে গেছে তোমার? আমার একটু এদিকে কাজ আছে।
ভিডিও সোর্স যে নেবে, কে নেবে সেটি বলতে ওনার কথা না, উনি তো ভিডিও সোর্স দেবে।
হ্যাঁ,
চ্যালেঞ্জটা কী হয়েছে?
ঠিক আছে। হ্যাঁ, তুমি ঠিক আছে। হ্যাঁ, বলে দাও।
আমি ভিডিও সোর্স গ্রিনটা অডিও ক্যাপচার কার্ড লাগবে, আমার কাছে আছে, সব রেডি আছে। অপোজিটের সঙ্গে কী জানাচ্ছে? ইন্টারনেট ফোন করে নাও। কলরগুলো কি কলরের কলিগ ছিল? কলরের কলিগ ছিল?
না ছিল নাকি ব্লক করে ছিল
কল্লো কোথাও কোথাও সম্পূর্ণ চেনে কল্লো তো আমার ব্যাগ
আমি আছে ক্লায়েন্ট
আমরা তো কম বেশি তাই আইটি আপনার কি আরেকটা চলে এসছে? হ্যাঁ
করবেন?
ক্যামেরা অডিও
ক্যামেরাতে অডিও লাগবে, এখান থেকে তো অডিও দেওয়া যাবে না এইভাবে।
আমি ওয়্যার দিয়েছি, আমি ওয়্যার দিয়েছি।
কই ওয়ারটা খোলা?
পাওয়ার প্লাগ
থেকে আউটপুট আমি পাবো? দাঁড়ান, আমি পাই কি দেখি না। এই আউটপুট ভিডিওটা লাগে
আসলে ভালো
আউটটা কই? এখানে কি লেখা আছে?
হ্যাঁ শোনা গেলে
এটা এই আসবে না আমার, তোমার হবে না।
লাইন আছে, লাইন আছে।
না এখান থেকে আসবে না, আমি অডিও নিচ্ছি এটা থেকে। এই আউটটা দিলে হবে? দেখি আপনার অত কিছু হবে না, আমি নিচে বসাতে হবে। মিক্সচার বসে নিলে পাওয়ার দেওয়া এই যে অডিও ভালো হবে।
এটাতে তো আমরা লাইভ করবো, এটা থেকে তো লাইভ হচ্ছে, তাই তো ডিপ কল হচ্ছে। প্রেজেন্টেশন লোকে যদি এটা থেকে তার সমস্যা হবে না।
ভালো শেয়ার করবেন, আমার ল্যাপটপ থেকে শেয়ার করবেন। আমি লাইভে মানে পড়ে এসেছি, শেয়ার করে দেবো। এইভাবেই রাখতে হবে।
তাহলে এটাকে তোমার সাইড করে দিতে হবে।
চার্জিং পয়েন্টের কাছে কি লাগিয়ে দিচ্ছি? চার্জিং পয়েন্ট এখানে আপনি শেয়ার করুন, আমি শেয়ার করতে পারবো না।
হ্যাঁ মানে এখানে জয়দীপ দা ল্যাপটপে থাকবে, প্রেজেন্টেশন দেওয়ার যে থাকবে সেখান থেকে HDMI লাগিয়ে দেবে।
চার্জিং পয়েন্ট ওটা ওখানে দিন, দিয়ে দেখুন যদি আসে। দিন আপনি দিন, বুঝে দেন ওখানে বুঝুন না, ওখানে যান আপনি, ওখানে অডিও আসছে কি দেখুন। হ্যালো হ্যালো হ্যালো, অ্যাম্পলিফায়ার অন করা। হ্যালো হ্যালো হ্যালো, হ্যালো হ্যালো হ্যালো, আসছে না? হ্যালো 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 হ্যালো, হ্যালো 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 হ্যালো,
সেদিনে করে গেলাম সেদিন।
হ্যালো 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 হ্যালো
চ্যানেল আছে কি?
হ্যালো হ্যালো হ্যালো, মিক্সচার লাগে আউট দিতে গেলে। আমার তো বলা হয়নি কাজ থেকে আমি কিছু হবে না। এইভাবে ওরা মানে ওনারা জানেন যে এইখান থেকে অডিও পেয়ে যাবেন। আপনাকে এমনি মাইক থাকলে এখানে যখন অডিওটা হবে ওইখান থেকে ক্যাচ করতে হবে।
ওটা তো সবই হবে,
ক্লিয়ার আসবে না, নয়েস আসবে।
আমাকে ক্লিয়ার মাইকে যে বলা হয় ওই জিনিসটা চাই আমাকে। মানে আরও কোনো কিছু আছে?
হ্যালো হ্যালো, এটা খুলেছিলেন না তো? ওইদিকে দিন। হ্যালো 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 হ্যালো, এটা সরিয়ে দিচ্ছে আমার লাগবে। হ্যালো হ্যালো হ্যালো,
Hello, check. Hello. Hello, check. Hello. Hello, check. Hello. Hello. Hello, check. 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 Hello. Hello. Hello, check. Hello, check. Hello, 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 hello.
বললাম তো আমাদের সামনে এসে
না মানে চালু হয়নি, স্টার্ট হয়নি, দেখা যাচ্ছে তো। আগে তোমার শেয়ার হবে এবার
Thank you.
আমার ল্যাপটপ আমাকে জয়েন করছে, আমি তো আমার ল্যাপটপ বসবো, রিপিট করেছি আমি।
হ্যালো চেক, হ্যালো হ্যালো চেক, হ্যালো হ্যালো চেক, হ্যালো।
বলো আমার কাছে আর এটা গ্রুপে মিটিংয়ে ইয়েতে দিতে হবে, চলে একজন আসতে পারবে না।
হ্যালো চেক, হ্যালো।
স্টার্ট হয়ে গেলে আমি ফোন করতে একটু আপডেট দেবো। না না, দুটো অডিও অন করতে তো এখন আপডেট তো আসে তখন তো তোমার যেখানে সুবিধা দিতে হাইলাইট হয়ে হ্যাঁ চলছে।
মানে এখানকার সোর্স কোথাও দেখানোর কথা আছে? মানে এখানে যে প্রোগ্রামটা ওটাকে কোথাও লাইভ দেখানোর কথা আছে?
এখনো মানে ইউটিউবে লাইভ হচ্ছে
চ্যানেলে কী দেখাচ্ছে?
কিন্তু এইখানে
না, আমার ক্যামেরার লাইভে উঠেছে, ক্যামেরা হ্যাঁ ক্যামেরা সুইচে তো যাবে, ওর ল্যাপটপ করতে যাবে। ঠিক আছে, আমার ল্যাপটপ আমি দিয়ে দিচ্ছি। হ্যাঁ মানে তোমার স্ক্রিনটা তোমার ভিডিওটাই পেয়ে থাকবে, মানে ওটা কীভাবে করবে? এটা সুদীপা কী করে
লাস্ট
রয়েছে?
জয়েন করেছে বলে স্যার কথা বলছে। এটা তো আমার শেয়ার হবে না।
না 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 না, প্রেজেন্ট ওটা তো জয়দীপটা প্রেজেন্ট ওখানে প্রেজেন্টেশন দেবে। হ্যাঁ, এবার ওই ক্যামেরাটা লাইভ হচ্ছে, ওই ক্যামেরাটা কোথা থেকে লাইভ হবে? ওই ক্যামেরাটাই তো লাইভ হবে। ওখানে কি লাইভ হবে? ওখানে লাইভ হওয়ার কিছু আছে নাকি?
এখানকার জ্যাকটা এখানে ঢুকবে।
এবারে আপনি কোথায় পাঠাবেন সেটা আপনি আমি সোর্স তুই ব্যাপারটা ক্লিয়ার নয়।
হ্যাঁ স্যার, বুঝতে আমার এখানে তো
মাইকটা চলছে কি?
হ্যাঁ লাইভটা
যদি তো এটা অডিও আসছে, অডিও ভিডিও দুটোই আছে। এটা কাটলাম মানে একবার দেখে নিই।
Hello, 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 hello. It's audible, no? Voice is clear? Okay. Hello, hello. Wait, can you start? Start. I lost it. Try, that's good.
হ্যালো, আমাকে ছুটতে হবে। শুভম বসা, ওকে, ঠিক আছে, লেখা হয়নি, আমি লিখে দিচ্ছি।
না এটা এইবার তো কালকেই ঠিক হয়েছে
লিখে দেব, এখানে এখানে লিখিস না, এটা ইয়ে হয়ে গেলে প্রবলেম হয়ে যাবে। হ্যালো, কত নম্বর টোটাল এখন ইয়ে হয়েছে, কত নম্বর টোটাল ইয়ে হয়েছে,
পাওয়ার কথা
এখন কত হয়েছে?
47
That is around, I think 20 companies আছে।
টপিকটা আগে বলবো,
হুম,
যে টপিকটা হচ্ছে রাখো।
ঠিক আছে, আমি বলে দেবো। So, can we start? I think further who comes, who will later join. Okay. So, good morning to all of you. So, I'm welcoming all of you so that we can start the workshop, one-day workshop with training series of 5 days for this data-driven manufacturing IoT 4.0. So, I will request Professor Sanjay Bhadro from EM College to give a welcome note. Please, sir.
Yeah, good morning everyone. Myself, Dr. Sanjay Bhadra. I am heading the Department of Electrical Engineering currently at the Institute of Engineering and Management, Newtown campus. It gives me immense pleasure to welcome you all to this workshop on data-driven manufacturing and industrial Internet of Things, IIoT 4.0. In this regard, I would like to extend my gratitude to Logarithm, IEEE Communication Society, along with K2N Academy, Rockwell Automation, and Phoenix for bringing together such a distinguished gathering of industry experts, academicians, researchers, and enthusiastic participants. This workshop is not just about learning new concepts, but also about understanding how data and connectivity are reshaping the future world. We all know Industry 4.0 is transforming traditional factories into smart, connected, and intelligent systems. The integration of IIoT with advanced analytics, AI, and cloud is redefining how industries will work in near future. This workshop will provide us with a valuable opportunity to explore the latest trends, share practical experiences, and discuss challenges in implementing IIoT 4.0. With these words, I once again welcome you to the workshop, and I wish the workshop a great success. Thank you very much.
Yes, thank you, Professor Bhadra. So, this workshop is organized by Logarithm in collaboration with III Kolkata section and IEEE ComSoc, IEEE terms, and in the campus of UEM. So we're thankful to Mr. Professor Sanjay Bhadra and his team to give an opportunity so that you got such a wonderful hall. So we will be doing this type of programs again and again for the industrial sector, because we want to actually bridge between this industry with your academy. I'm very hopeful that the students will be getting very beneficial from this gathering, because I think 80% are from industry, from core sector, manufacturing sectors, and your academy. So let's continue. Our next, I will invite Mr. Shubhamay Chakraborty. Is not there. Okay. So, should I call the next accordingly? So I will invite Dr. Pallab Ganguly, Chairman, IEEE ComSoc, Kolkata chapter. Sir, your dais.
Good morning, ladies and gentlemen. So I'm very happy to see all of you. You will be having a lot of exposures with respect to the operational technology system. I think Phoenix, as well as Rockwell, with whom I have been working for the last 25 years in Calcutta Electric Supply. So I have commissioned multiple PLCs in the generating station, the RTUs, FRTUs of Rockwell Automation. I am well aware of Rockwell systems. So to give you a small snapshot of my biography, I am basically an electronics and telecommunication engineer, having masters in technology from Jadavpur University and PhD in computer science in the capacity of smart grid cybersecurity. So smart grid in a term is a juncture, is a collaboration between IT, telecommunication, power grid, and whatnot. Now, in this capacity of 26 years in a power utility, 25 years in a power utility and total exposure of 26 years, which has given me a very rich background of IT, telecommunications, as well as power systems and power technology. And if I'm not wrong, Professor Bhadro is from electrical engineering. He's an alumnus of my university, Jadavpur only, electrical. He has done his master's. So he knows that in any power utility, the function lies within the distribution, transmission, and last but not the least, generation. So what do we have in distribution? In any distribution network, to give you proper quality, harmonics, free electricity, we have to give you through distribution automation program. We have a state-of-the-art OSI SCADA systems with industrial control systems embedded with energy monitoring, distribution management, as well as outage management. So many of you might be our consumers of West Bengal State Electricity Distribution, India Power, or DVC to some extent. But I tell you, when you go into the generation era, in the generation systems, the entity mainly is the distributed control system. And the distributed control system basically works with the PLCs. It works with different vibration system because the boiler, turbine, and generator are the best resources of power. If you don't get proper generation of electricity, how could you transmit it properly over an optical ground wire and bring it to the city of Kolkata? That we have done from Haldia Energy. It's a state-of-the-art commissioning and the highest tower in Asia. So I tell you something of your subject now, that is IIoT, which we say Industrial IoT. Having protocols like MQTT, very important. And since I work on the cybersecurity part of it as well, being a smart grid engineer, I also work in the cybersecurity domain for critical information infrastructure. And we work with CA Ministry of Power, NCIIPC, that is National Critical Information Infrastructure Protection Center, under Mr. Ajit Doval, the Chief Security Advisor, Prime Minister's Office. And also we work with CERT-in, Dr. Sanjay Bahel, that looks after the computer emergency response team. That is the response mechanism, incident response team. We also work with various Department of Ministry of Home Affairs, Government of West Bengal, since I am in the capacity of member WB CERT, Government of West Bengal, and also in various expert committees with the Government of West Bengal. So I tell you one thing, the opportunity you will get into this operational technology that is a critical part of any critical information infrastructure which deals with the national security, national economy, public health, and public safety. These are the four mantras, ladies and gentlemen, which you should always remember: nation first, always first. So to protect the critical infrastructure of our nation, of our state, is the main motto. And whatever you are learning, you take it as an opportunity, because this digital twin, smart grid, smart city, these are all parts, green place for you to work. Those are greenfield projects. Smart grid is still greenfield for third world country like India. Smart city is a greenfield project. IoT sensors, IIoT, Industrial IoT, Industry 4, Industry 5 is coming. I'm also working with the Standardization Forum of Bureau of Indian Standards, Smart LITD 10, as well as IEEE P2784 Smart Technology Guide on Smart City. So I would tell you, this is an opportunity. I'm thankful to Phoenix. I'm thankful to Satyapriya Das for organizing this from Logarithm. Great thing, Satya. I must applaud you. A big applaud for Satyapriya, because I've been trying this academia and industry collaboration for the last 25 years being in IEEE. Being a senior member, I always wanted the students to visit the industry, and if not, let the industry come to the students. Now the time has come, not only the students should go for vocational training, but all the industry leaders must come to the students, to the faculties. And without quality faculties, you cannot have good students. So, Professor Bhadro, I would tell you, please arrange for faculty development program first in all private engineering colleges, maybe it would test you a better sense. But I tell you that IIT, Jadavpur, ISI is not mandatory for anybody to become an engineer. If you go to quality private engineering colleges, you will get better education. So we should always try to first have a quality faculties, do quality faculty development program. Then only you will have good students. So if the faculty is not up to the mark, how could you get good students? So my honest request to all of you is that don't think that you are not from premier institutes. Maybe IEM, Techno, there are many institutes which are very good institutes in terms of some department, better than IITs and Jadavpur. Because here you are getting a live opportunity to see Phoenix, and have they come? Rockwell Automation has come. They are on the way. So Rockwell, they will give you the industry exposure. What happens in a process industry? May not, you leave power aside, but you have process industry. In process industry, what do you have? You have sensors, you have devices, you have analytics, you have digital twins. When we are thinking of smart city, we are thinking of digital twin. Whatever we have in on-prem, we must have a similar virtual infrastructure in the cloud. That is digital twin. To have that particular digital twin get implemented, we need engineers, we need faculties, we need good people from the academic background to come forward and do this request for proposals. Once you have good requests for proposals, you will have good order, you will get to know the project, you have a good scope of work, and you can commission it. I think the Rockwell team has come, with whom I have been working for the last so many years, and I'm sure they will take you through. And my request to Phoenix and Rockwell is, please let them know about the PLC system, the RTU system, the FRTUs used in the power industry. Let them know the process industry sensors, devices that communicate for humidity, temperature measurement in any power plant or any other Hindalco, any aluminum plant. Give them the real-time experience. That is most needed in today's world. Thank you so much.
Thank you, Dr. Pallav Ganguly. Thank you for your speech and valuable information. And the next, we will be facilitating partners. Mr. Satya, so the next program is for facilitation, right? So I think IEEE, Mr. Subhamay is not there, so they will later on. So I will invite Dr. Pallav Ganguly, please be on the dais. So our director, Satya, will be facilitating you with Thank you. So next, I will invite Professor Sanjay Bhadra be in the dais, and I will invite our Joint Director, Mr. Promit Niyogi, to facilitate Professor Sanjay Bhadra. Thank you. Next, I will invite Mr. Kollol. Kollol sir, be on the dais. He is from Rockwell Automation. Sir, I will request our director, Satya sir, to facilitate Mr. Kollol. Next, I will invite Mr. Subhrojit from Phoenix to be on the dais, please. And our joint director, Mr. Promit Niyogi, will facilitate Mr. Subhrojit from Phoenix. Thank you, Subhrojit. So, about the inception of IoT and its implementation.
Before that, I have a small request for we have Tamalnath from Ddm-Iiot.
Okay. Okay. Mr. Tamal Das from Ddm-Iiot. So, Mr. Satya, please facilitate him. Thank you. So, I will invite Mr. Ddm-Iiot from Logarithm Consultancy Private Limited to give some lecture on the inception of IoT and its implementation. Ddm-Iiot.
Hello. Very good morning to everybody. And thanks to UVM for allow us. It is a nice environment for this event. Mr. Pallab Ganguly has already explained the basic theme of the event that you have already acquainted. And now I will give you a short description of what way you would proceed. We would proceed one by one. There are many experimental events are there. You will see, and it is a great opportunity for you, all participants, to interact with the practical interfacing of IIoT by means of some Phoenix hardware. And we also have a very interesting presentation from Rockwell Automation about optics, FT optics and digital twin. So one by one, you will have the your opportunity to even you can directly control some of the parameters from your mobile phone. That is extremely interesting for this. You will get a greater exposure how we use different protocols. There are good presentations obviously from the Phoenix and Rockwell, how the protocols we are using for developing an IIoT. First IoT and then industrial IoT, basically all industrial devices like say motors, blowers, fans, which we normally use for the industrial purpose and process control, that each of the things is connected in the internet network. I think many of you, those who are coming here and presenting here, have a little bit idea about the IIoT because you are from all manufacturing industries. And I also request all the students present here from UVM, you will also definitely you will also observe each and every experiment we will demonstrate after that, after my lecture, and you will try to participate in the hands-on. It would be very much helpful for you. And if you have any questions during the lecture session, you are feel free to ask any questions to our speaker. The speakers are very eminent, one from the Phoenix and one from the Rockwell. They have great experiences and they are really hands-on experiences, which is very much important for all of you. You should share your questions with our expert speakers, expert engineers. That will be very much helpful for you. So all you are coming, I will welcome all the participants that you are coming the far distance from the West Bengal even. And it's we are very happy, and it is a great privilege for us that all you have gathered over here for participating in this event. Definitely nowadays, IIoT, Industry 4.0, this Industry 4.0 ecosystem is basically with the IIoT, cyber physical systems, machine learning, robotics, and all. We have our next future, we have our long plan to organize these kinds of events in terms of different new technologies. So it is our first starting point. We are, and the starting point, we are getting such a response from you. It is really, we are overwhelmed. And what I can say that Dr. Ganguly has already said that our director, Mr. Shotopriyo Das, has taken a fantastic venture. His endeavor, we really appreciate his endeavor, that nowadays he has selected the topic. Nowadays he has selected a very interesting topic, which is IIoT, which we are going to organize right now. So I will not waste any more time. I think you will be ready for the subsequent lectures, which will be given by Phoenix and Rockwell. And after that, after lunch, we will start our hands-on. So thank you once again, all of you, all the participants, you are gathered over here. So thank you. Hello. Now, you are coming from the different locations and different companies. So, can I request you, please just 2-3 seconds, you just give your introduction. You, please.
No, be seated.
Be seated, no problem. আচ্ছা মাইকটা একটু ওনার কাছে মাইকটা একটু ওনার কাছে ওয়্যারলেসটা because many of them
You want to understand business
because you see you are sitting idle, you see myself, I want to see you more in detail, because you are if your introduction we get, then it would be helpful for us to move and to organize the entire event successfully. So you please your দীপায়ন তুমি একটু দেবে ওনা তোমরা দাঁড়িয়ে থাকো. It will be shifted one by one. You sit and you speak your name and just 2-3 seconds your introduction. Start please.
Okay, I'm Bivas Vaidya. I'm from Himadri Specialty Chemical Limited.
Okay.
And I am looking IT and system the organization.
Thank you. Please pass it to.
Myself, Amit Kumar Datta, came from Himadri Specialty Chemicals Limited.
Yes, yes.
Himadri Specialty Chemicals.
Okay.
I am looking for IT and systems.
Okay, okay.
I'm Arun from VFS Capital.
Okay. Your designation, please?
Senior Executive for IT.
Okay. Sound about it.
I am Mizanur Rahman from BFS Capital Limited. My designation is IT.
You are IT.
BFS
You are from IT. Okay.
Senior executive.
Okay. Next.
Good morning. My name is Jyotish Roy. I am assistant manager for IT in Super Smelters, and I manage the CRM of Super Smelters.
Oh, yes, yes. Okay, okay. Please take your seat.
Good morning all.
Good.
I am from Link Limited and I'm heading infrastructure over there.
Okay.
Good morning, everybody. I am from Link Limited. I manage IT in SAP system.
You are from IT. Okay.
Good morning all. I am Subroto Sarkar from Pattern International Limited. I am looking the IT infrastructure.
Okay. In the first hand. This.
Good morning everyone. I am Rohan Bhavik from Indorama India Private Limited. My department is the IT and system.
Okay.
Good morning. I am Sanjay Das from Indorama India Private Limited. I am assistant IT manager.
Okay. Thank you. Sir, please.
Good morning everyone. My name is Rishi Prasad. I am senior manager IT at Super Smelter Limited.
Okay, okay,
Thank
okay,
you. Good morning everyone. I am Anirban Sinha from Visa Coke Limited, Odisha. I am looking after the IT infrastructure as well as SAP activities in my company.
You are coming from Odisha?
Yes, I am coming from Odisha.
Thanks once again to you. Please.
Thank you.
Good morning to you all. Myself, Martin Lakashyang. I came from Star Cement Limited. Probably we came from our team. We have two. We came from Star Cement Limited, Murutlan. That is from the Meghalaya. We are looking here mostly for the how can we implement the IoT system in our manufacturing company.
Okay.
You are coming from?
Star Cement Limited.
Star Cement Limited.
Star Cement.
Your
Yes,
location. Your location. You are from your company.
From Meghalaya.
Meghalaya.
Yes,
Meghalaya. Please, thank you. And welcome once again to you.
Hi, good morning all.
Okay.
I am Jonas Suchang. I am from Star Cement Limited, Meghalaya unit, and I am working in IT department.
Good morning everyone. I am Subhojit Sawi and I am coming from Samsung Industries Limited, and I am working in their IT department as a technical project manager for their CRM projects, and I am looking for better understanding the technologies your workshop going here.
Thank you. Madam, please.
Good morning everyone. I am Bipula Banerjee from Graphite India Limited, IT department.
Good morning everyone. I am Tanmay Bhattacharjee from Graphite India Limited, Senior Manager IT.
Good morning everyone. Myself Prosenjit Das. I am from Ddm-Iiot Industries. I am taking care of IT infra.
Good morning everyone. My name is Abdul Qadir and I am working in a Amrit Cement company. Entire IT, I will take care of entire IT of Amrit Cement from IT department.
Good morning everyone. Myself Archana Jha from Amrit Cement Limited in IT department.
Hi, good morning everyone. This is Roopsi and I head the IT infrastructure and cyber security practices of Gainwell Group. Thank you.
Good morning everyone. Myself Ajay Kumar Yadav from Himadri Specialty Chemical Limited, and I am taking care of infra lead operations.
Once again, please.
Myself Ajay Kumar Yadav from Himadri Specialty Chemical Limited, taking care of infra lead operations.
Good morning, everyone. I am Sudipto Dev from UM Kolkata from Robotics and AI Department.
Good morning, everybody. Dr. Chaudhary from New Animal Works, Kolkata, heading the process planning department.
Good morning, everybody. Deepanand Basu from New Animal Works, Process Planning Department.
Good morning, everyone. I'm Suman from Sikibilla Hospitals Group, and I'm looking after the IT department. This is technically actually for the security department.
Good morning, everyone. My name is Shurit Sensama. I am coming from Sikibilla Hospitals Group, and I am from IT department.
Good morning, everyone. My name is Shurjit Nundi. I am coming from Senisa Technologies Limited and taking care of IT infrastructure department.
Good morning, everyone. Myself, Niladri Shekhar Vishwas. I am from Senisa Technologies, Assistant Manager, IT Infrastructure.
Those who are coming from the industry directly, I will go to the student later on. Please, you explain.
My name is Harshita. I am from Electrosteel, working as GET in IT department.
Hello, my name is JP Yadav. I am from Electrosteel Castings Limited from IT department.
Good morning, everyone. I am Shubha Nandi. I am from the Department of Robotics and AI, currently pursuing BTech. I am in my third semester. Robotics and AI. Yeah. Yes, sir.
Good morning. Sudhanshu Goel, Hindalco Limited, Silvassa.
Good morning, everyone. I am Vikas Pandey from Hindalco Industries, and I am working as Deputy Manager in Digital and Automation Department.
Good morning, everyone. I am a student from University and University of Engineering and Management, BTech first year, IoT and Cybersecurity Blockchain Technology Department.
Thank you. So, in our this IoT workshop, so two OEMs are representing. One is from Phoenix and one is from Rockwell. So, I will invite Mr. Shubham from Phoenix to give introduction about this Phoenix, what you are dealing with. So, and the experiments that we will be doing.
পিছনে প্রেজেন্টেশন মোডটা
Laser. So good morning, everyone. So thank you, UEM and logarithm. So thank you, UEM and logarithm, to arrange this seminar. And today we are discussing on the topic is data-driven manufacturing, and which is IIoT, Industry 4.0. So this today's world, actually the industry is changing. So today we are in Industry 4.0. So this is basically data-driven and basically more on software. So to run this software like AI, ML, and this the data in storing in cloud and communication part. So you need the hardware which will be reliable, which will be industrial grade, and which will be also it will be economical. So Phoenix Contact is a company which is provide this type of hardwares in industry. So let me introduce myself. I am Shubham Basha. I am Deputy Manager for the Eastern Region Business and Bangladesh. And I have a total 13 years of experience for the automation and the sensors. The both industry I have been worked for the 13 years. Right now I am taking care of the industry automation business in Phoenix Contact. So let me introduce my company. It's a Phoenix Contact is a German-based company. It's founded in 1923 Essen, and its headquartered is Bloomberg, Germany. Also, we have a production sites in Germany. It's almost 5 production unit. Also, we have production units in 10 countries, and we have a subsidiaries of 50 international countries. So next is competence center, which is actually our R&D center. Once we are develop some products, so we need to taste the hardwares, and for that we have a quality and R&D centers. Now we have 3 competence centers. One is in USA, one is in Germany, and another is in China. So next year onwards, we have already proposed in India. We are opening the R&D center in Delhi. So this is a next slide for the how the Phoenix is developed their business. In 1923, it was founded in Essen, and we start our business with terminal blocks only. So most of the industry, they know Phoenix as a terminal components, all these things, because this is our first business we started. And after that, we have grown in that way in the automation sector. And we have almost total 1 lakhs products basket in Phoenix Contact. And also after 1981, we have different. We are already in different countries. We have subsidiaries in different countries. So next is Phoenix Contact India is a 100% subsidiary of Germany, and we started our operation in 1993, and our headquarters is in New Delhi, Okhla. Also, we have production units in India. It's in Haryana. We have a quality lab in Delhi. Also, we have a engineering and technology center at Pune. Also, we have regional offices in Kolkata, Mumbai, Chennai, Bangalore, Gujarat, and also we have different engineers. We have engineers located in different cities also. Now we have more than 2,000 employees in Phoenix Contact India, and we have 1 lakh plus products in our product basket. So in after 2012, the Finnish contact, you know that we have 1 lakh products. So we have divided these products in 3 verticals basis on the products. So one is device connector, second is industrial components and electronics, and third is industry management and automation. So we are actually I and Mr. Subhraj Das, we are working for the industry management and automation division. So next is for the industry perspective, we have a 4 industry vertical we are focusing in the market. One is energy, like energy generation, energy transmission and distribution. So for the energy generation and transmission distribution part, we have RTU, FRTU already supplied in different projects. Also we are doing the solar projects and the wind power projects. So for the energy, we have a very good footprint in the market. And second is process industry. Process industry, we are not in the core section, but we are in the auxiliary systems. So auxiliary systems we'll discuss once we go to the next presentation and the demo part. You will understand what type of application we are doing in process. And next is infrastructure. So now infrastructure we are working for the water and wastewater division. And for the for this water and wastewater division, we have a more than 70% business we are doing all over India. And next is building technology, smart city project. Like now it's a growing industry. So right now we are in the building automation division also. And next is factory automation, like all over the factories for the digital factory, like IIoT, everything is now required for the factory automation industries. So these 4 industries we are covering as per industry. So I come to the product overview. So right now we have a 1 lakh product basket. So you can see that we have actually we are the panel component manufacturer. Previously we were panel component manufacturer. Right now we are focusing on the automation section also. So you can see just you can see this is the connector, tools, the printer, and the terminals. All the things are actually manufactured by Phoenix. And now we for the IoT systems, whatever the relevant products we are discussing in the next slide. So now I come to the our automation products. This is a PLC. You all know about the PLC because all the industry people you are also you are also using this PLC in your systems. So this PLC actually based on the IEC 61131 category. So you can just write a program, a ladder logic through ABD, through STL. So this is our basic level PLC. So we have the all products, like we have a small modular PLC and the redundancy PLC we have. So next we have the PLC Next technology. This is actually required for the IoT solutions. This is a PLC. You can say PLC, but this is we call this is PLC Next. This is the controller, which actually which has the MQTT protocol inbuilt protocol. It have. Also, this is an open protocol PLC. Like if you go to the Siemens, they have a dedicated communication protocol is Profinet. If you go to Rockwell, they have a dedicated protocol of Ethernet IP. But for us, this is an open protocol PLC. We can talk any of the any type of PLC, any type of protocol. So this is our PLC Next technology for the IoT solutions. Also, it has the inbuilt MQTT protocol features. Also, this is a cyber secured because now it's security is a main thing for the industry. So PLC Next is a cyber secured PLC. So also it's a VPN VPN enabled PLC. So you can connect to the PLC to our cloud it's secured, always secured. So we just share the more details on this controller, and more interesting features we'll discuss on the later. So now we are discussing on the PLC, and next is like we are using the PLC in the industry. Now we have to get the data from the field. For that, we have different type of I/O cards like digital input, digital output, relay module, analog input, temperature, and safety modules for the safety purpose application. So, and after getting the data from the field, we have to visualize these, like display these data. For that, we have HMIs, we have panel PCs, also we have a box PCs. What is the, now you can say that HMIs we are using in the industry is a HMI, which is actually runtime based. Now we are developing the web page SCADA, web page type SCADA. We are monitoring the data in mobile, in a web page. So we want to see the same thing in our shop floor. So you have to use the this HMI, which is web page enabled HMI, which is actually useful for the shop floor. You just develop your program, your SCADA in a web page, and you just monitor through HMI, web page based HMI, which is available in Phoenix. Next is box PC. I will go detail in the next slide for the box PC. It's a fanless PC. So if there is any dusty environment is there, so for that we are using this box PC. Next is panel PC. It's a HMI, and the backside there is a CPU is on board. CPU is there. So for the box PC, we have a Celeron type from Celeron to i7 processor. So like you can see, the based on performance and the cost, we have a multiple products. This is a tailor-made box PC. If you require any type of like you are using normal PC in your industry, but sometimes you will facing some problem where is the dusty environment is there, the normal PC will fail. So for that we are proposing this type of box PC. So internal part of this box PC, like this, as it is it's a fanless PC. So we have a passive cooling heatsink inside of this PC, and we have different type of interfaces available in this box PC, like COM port is available, like Ethernet port is available, USB port is available. All type of port is available, which actually in industry, if there is any old protocol is available, for that this PC can work. So next is a communication interface. Like we are getting the data from field, we are display all the data, but in between that we need a communication part. For that, Phoenix has different type of products for the communication. So for the Ethernet, this is a managed switch we have the unmanaged switch, and for this data security, we are this is the security purpose, we are providing mGuard. This is actually if you your PLC or any controller is not secured, the cyber secured, then we are providing this type of mGuard. This is a firewall we are providing, hardware firewall we are providing to the industry. And next is the 4G routers we have for communication over GSM. Wireless solutions or solution like where the GSM technology is not approved, like once you are going to government plant, government industry, so they are not actually some industry they are not accepting the GSM based solution. For that we have a wireless solution which is capable up to 5 kilometer distance of communication. So next is like PoE switches. Now all of the company they are using CCTV cameras, all like everyone is using CCTV cameras. So for that PoE switch is required, which is actually Phoenix manufactured this product. Another interesting product we have is Ethernet extender. Like once we are communicate from one control room to another control room over fiber optic, like once a distance between two control rooms or PLC is more than 1 kilometer, then we are using fiber optic cable. So this is a Ethernet extender where we are using normal copper wire instead of fiber optic cable. So we have to place one Ethernet extender one end, and another end we are placing another Ethernet extender like media converter. And in between that we are using 2-wire copper cable and 4-wire copper cables. So for 2-wire copper cables, speed will be 15.3 Mbps, and for 4-wire it will be 30 Mbps. But the distance between two extenders should be 20 km, maximum 20 km. So there is a different protocol is available, like Ethernet to Ethernet, Profibus to Profibus, and serial interface to serial interface. In between that, we can use the copper wire instead of fiber optic. We have the similar media converter also we have, like we are using the copper wire, but we can use the same fiber optic. That product also we have. Next is the industrial wireless product. This is a very interesting product for the Phoenix product basket, because right now what I am telling that each and every industry, they are not accepting the GSM technology. For that we are giving the solution on wireless, which is like we are saying the data, the IO data, like DIDO, AIO data from one end to another end. For that we have a radio line solution, another is a wireless MUX solution. And next is for the serial interface, like we have a RS485 communication protocol available in the field, and we want to send the data over wireless. For that we have a radio line solution. Another is essential, like this is a made in India product. This is a made in India product. So this type of product we have. And next is the Ethernet wireless, like you want to transfer the data like Profinet data, Ethernet IP data over wireless. So we have a WLAN. Next is Bluetooth based wireless solution. Another interesting thing is we have near-Fi technology. This is like we are using for this near-Fi technology, basically a new technology. With this product we can transfer the data as well as the power. So power and data we can transfer through this module. And for the industry guys, I think you all know our power supply products, because this is our key products. Like we are very much premium on this product. So we have a essential series product. Next is Quint. This is a essential, like this is a made in India product, which is we are giving to the customers. And next is a step power for the building automation products. Next is a Uno power. Next is a Trio power. Next Quint power, and the last is Quint 4 power. So how we are going to actually divided these products actually based on the features and the rating. So what we are doing, we just for the automation team, we are doing the customer, we understand the customer requirement, and then we design the basic design this requirement, and we just submit a document to the customer. And customer, once they approve the document, we just code according to that we code to the customer, and we supply, install, commission all the part, and hand over the project to the customer. And if there is any problem, we just do the after sales and service. So this is the total product portfolio from Phoenix Contact. And if you have any question, you just ask me, or we can discuss during the tea break if you want to know more about the products of Phoenix Contact. So thank you everyone, and next I hand over this presentation to Mr. Subhrajit Das, my colleague of Phoenix Contact. Thank you.
So good morning everybody. So myself Subhrajit Das from Phoenix Contact. So 5+ years experience in this Phoenix, and total 19+ experience in this total automation. myself Subhajit, looking after the business of Phoenix Contact. So Eastern region and Bangladesh. So Eastern region means West Bengal, Odisha, Chhattisgarh, Jamshedpur, Nepal, Bhutan and Bangladesh. So there is three verticals already my colleague Shubham explained. There is a device connector, components, and there is a industrial automation and solution business. So we are looking after the solution business of the Phoenix Contact on this vertical, where we can give the complete solution to the customer. So along with this Phoenix product. So myself 19 years of experience and total in this automation field. So my previous in the Philips 10 was the company, and now I am serving the business development and sales for this Phoenix Contact. So related to the IoT and IoT product of the Phoenix, already my colleague Subham explained what is the product exactly using this IoT platform. So now I just little bit brief to this product exactly what to do and what is suitable for this communication. So this is our controller where we can say there is a Phoenix portfolio, there is a 1152 is the normal series of this IoT gateway, and from this edge computer also we have. So the basic line series normally IC61131, which we can do the programming only the ladder and FBD and ST logics. But here is a main USP of this Phoenix. So you can use the ladder FBD also and the high level language also. So means C, C++, Java, Penguin, .NET, any type of high level language you can program it in your open platform in this, your laptop or computer, and you can download to the C-type cable on this controller. So directly it will work. No need to any third party language or no need to any platform to do the program, or you have to know the ladder or FBD. So just forget about it. So if you know the C++, so you can do the program and download it. So this is our Axulence series controller, which acts as a IoT, taking the data from the field and sending data to the cloud and any type of field device, any type of computer or IoT platform. So this is the baseline, is the 1152 is the hello. So in first we can say the 1152 and there is a RFC4072R. So there is a different type of controller of the gateway where the RAM base, processor base, and in the different IO handling capacity we can segregate these 3-4 devices. So it is the lower version to the upper version we are proposing here. Now the smart secure system, what we can say, there is a lot of protocol like MQTT, HTTP, SMTP. So every type of protocol is a support in our this controller. So OPC UA supports, DNP3, the latest protocol also support this controller. And if there is a DI, DO, AI, AO also in the field capturing the data from the field, so we can add is the add-on card with this controller in the side base and directly data fetching from the sensor or any devices from the field and sending the data. And this is the cyber secure controller. Why? Because this is fully integrated security system is there. So IEC 634-2 and 4-1 cyber secure certification we have for this type of controller in this Axulence series. Because this is a cyber secure controller means you cannot hack this controller. So if you access this controller, so we have to use the user ID and password. And it is different hierarchy level you can set this password. And this controller can send the data any type of cloud like AWS, Azure, Prophet Cloud or Google Cloud, any type of cloud you can directly send to this Ethernet cable. Like inbuilt, this controller acts as a Microsoft operating systems and Red Hat Linux also, because you can operate as a program in this Red Hat Linux also. So there is a different protocol you can directly code basis as a JSON format you can send the data, or you can API format also you can send the data. So there is a different protocol also is inbuilt. So you can use as a Linux based command prompt, or you can use as a Microsoft based, means one Windows operation. So what I told that the Node-RED is in now latest, and Python also now latest programming function also you can do. आवाज नहीं होगा ना इसमें?
Hello.
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 So limitless adaptation capability is thus the Node-RED is the now latest language, and Python also the latest language, so everyone knows and doing the program in this Python and Node-RED. So Node-RED you can do the program in normal platform in this controller, and Python you can, like Anaconda, you can download in your computer, and you can do the program through this Anaconda and send it to this controller. So cyber secured is a certification is the IEC 62443-4-1 and 2. There is a 2 certification in the worldwide. So we have only the Phoenix have in European country and all over the world have a cyber secured controller. So nobody have owned this certification. Now recently, 1 month before, the Siemens have a cyber secured controller launch. Last 3 to 4 years we are leading this market, this cyber secured controller. So we have a certification also, and we can propose to this a new guideline in the every tender, every document in this plant or any power plant, process plant. So cyber security is the must because of the hacking. So this is our certification, and this is the NABL test report and the VTL report, which is authentic to propose to the customer in the industry level. Now this is the controller we can use as a edge device also. What is edge device? Because it is connect to the OT and IT platform, just handshaking this edge device. Because you have a third-party PLC or any type of instrument in the field. So instrument, there is a automation field instrument, we can see there is a level 0 products, means in the field like a sensors, like a motors, everything is in the field level, so level 0 product. But they are not capable to send the data to the cloud because they have only the digital output, or they have a digital input we are taking, or the analog signal 4 to 20 milliampere or 0 to 10 volt we are taking. So this type of instrument, if we want to send the data to the cloud, or we can collect the data to analyze the data for this IoT purpose, so not possible. Recently the new instrument like Andres or any XYZ company, so launching the instrument to directly send the data to cloud, but they are very much costly. So for this case, and also our existing plant like Electrosteel, Himadris, and they are installed a lot of years back, the normal 4 to 20 milliampere input signal instrument or a digital, so they are not able to change also with this cost optimization, so they can use our product to taking the data from the field or any type of third-party PLC, like a existing DCS is the big type of DCS, or any type of PLC is there, so they can directly take the data from from the field to our edge device. And this edge device you can connect to the internet for the sending the data to MQTT protocol to the cloud, or you can connect the physical server or physical laptop directly to the Ethernet LAN port, RJ45. And for the IT systems, any type of IT systems can take the data any type of language, like API, JSON, HTTP hosting, IP, you just ping the browser IP and just taking the data. Obviously, there is the user ID password is required for this cyber security. So there is a checkbox in this controller, so you can check the cyber secure data or not. If you use the cyber secure data, so then you can check this box and you can pull the data with your authentication. And one more concept is the hardware, it is in cyber secure, but the communication may be somebody, it is connected to the switch, managed switches or unmanaged switches, but somebody service engineer came and they plug in their laptop to these switches. But the communication is not the cyber secured. Your controller is secured, but between the planned data is coming to these switches and to the upper level and the lower level. So there is a communication is not the secure. So for this case, we have a device on this firewall. So this firewall is protect, this is the 4L, as the local access, network cell, and the network and the remote access. Because your controller is secure, but I am accessing from here in Calcutta, your another location like a Sam Steel, Jamuria, or Himadri Steel, Singur. So, but this communication is not secure. So for this case, you have to procure or you have to install this type of device like a firewall, hard firewall, that secures the communication line. What? Because controller have a VPN technology and this product have a VPN technology. So between the label, the controller or from here, so VPN tunnel will create, and through this VPN tunnel encrypted data sending from here to there. So that way you can secure your data through this communication. So for this purpose, the firewall, hard firewall we are using the industry. And OT and IT both the convergence this product is uses. So Phoenix Contact is a product based company as a OEM. So we are using the product as a solution the overall. So this is our Ddm-Iiot solution where you can use the high availability of integrity monitoring also for the total data or some of the security information, event management. There is a all our web-based platform you can configure these devices. So that devices no need to any software required because you just open the device and connect to your laptop to the RJ45 jack and any type of browser like a Google Chrome, Microsoft Edge you just open and you can configure through the browser this device. So one example which way I'm talking about like a HMI PLC, it is on level 0 part and there is on the field, but you have a IT firewall also and you have to secure the data on the field level. You have to connect this firewall device with the communication is the secure. Your controller is secure. So nothing worried about the hacking. So this is OT and IT, the between these our product is very successful in this market. Like one example I am showing here. So there is a summon machine and from there, so you can, some of the cases I can give the example, your one plant is located in the outside of India or any remote places of India. So going there, the engineer is going there and coming here. So it is very difficult to one-day service. If you use this device, so you can directly communicate to this device and upload, download the programming from here. Means you should be IoT enabled because the internet is required, otherwise communication is not possible. But internet is not open, so it is a VPN secured internet. Means it has an inbuilt software that can connect the encrypted data from one node to another node. And the remote sensing and the GSM technology one is, so remote sensing, we can say there is a some of field devices is there. There is a lot of option to taking the data from the field. So maybe there is a cable, maybe the copper cable, fiber cable you can connect, maybe the hardware cable is the RIO concept, we are taking the data, but some of cases there is a very difficult to lay out the cable in the industry. For that case, we have a modem on that. So modem, exactly what to do, there is a SIM base. So GSM SIM you can directly put in this device and it will give the internet connectivity. And also this is acts as a firewall and the VPN also, because that module have is a VPN connectivity protocol and the firewall it is an inbuilt. So this is a 4G router. This is a single SIM base in the Phoenix portfolio. The give and connect to your any type of controller, any, not only the Phoenix, any Siemens, Rockwell, ABB, any type of DCS or controller. You can connect this with a Ethernet port, with a RJ45 port, with the Ethernet cable, and it will give the internet. And your controller will be internet feasibility. This is our the dual SIM router where the two 4G SIM we can use this. Because what is the reason behind this? Sometimes the Vodafone SIM you are using, but Vodafone SIM is not working in the remote area on your plant. So there is Jio is very much okay, or BSNL is very much okay. So you can put it the two different company SIM on that module, and if one SIM is fail, another SIM is working fine. So it is a redundant communication also have in this module, because sometimes what happens, the SIM is not capable to take the tower and just go drop your connectivity. On that purpose, the ear communication will be the secure and ear communication would be stable, because we have a two SIM. So if one SIM is fail, so another SIM is giving the connectivity. And also there is a auto restart facility hub. Sometimes we see in our home also some of commercial router which are using like a Geo Fiber, or it is a hang. Sometimes we have to go to the restart this router also. But here have a facility to auto restarting capability, because if you put one Amazon.co.in or Google.co.in or your university like some of logarithm.co.in is the particular the authentic site, you can put it inside that one place. All time after 1 second or 2 seconds, it is pinging that site, and if the TTL request is okay, so that means connection is okay, no SIM is failed, so the communication is okay. Sometimes TTL request is 0, means the communication breaks. So two SIM, one SIM check and second SIM also check. At the two SIM going down, that minutes or 10 minutes, whichever time you can set is the customization. So it is auto restart. So no need to go to the manual restart there. So it will auto restart and restoring the signal to the SIM. Restart from remote also, because there is a program is there.
If you have any questions you want to interact with our speaker, you can ask your question, please. If you have any questions from your department or your division relating to these topics, you can feel free to ask any questions.
Yeah. Okay. So there is an auto restart facility, because you have to set the ping, the address, or you have to set the time of duration, like if 5 minutes it is not coming the pinging link, then it will auto restart. Okay, so this is one of our products, and there is a dual SIM, and one more is somewhere is in the field we have is a SIM is not working because in remote places. Also there is a moving element is going, so there is a no optical fiber laying is possible. So copper are also not possible to taking the data from the instrument to your RIO panel. That case, we have a devices, we can say the trusted wireless. So trusted wireless, my colleague already explained. So that is the radio line product. So what is the radio line product? So that is the data coming from the field, and the another side you have a device. So transreceiver, the data means one is transmitting, one is receiving. But our device, the both way communication is possible. Means the transreceiving means one with send can receive also. Second one also send and receive also. Up to 2 kilometer you can send the data through radio wave. 2.4 gigahertz is the free band in our India. So the frequency is going from one side to another side with a 2.4 gigahertz band up to 2 kilometer without wire. So it is the radio line product. And one more USP we can say in the Phoenix, that the digital input you have, digital output you have, but you need here the Modbus data. So you can directly connect to this digital input, digital output, analog output, and you can take the Modbus, because the Modbus port also inbuilt. So Modbus RTU, RS232, RS485 also there. But if you need only the Ethernet, that also possible. If you have an energy meter, so you can connect the Modbus, but you here required any Ethernet data or any type of digital input output data, that also possible. So radio line. And also one more is the serial communication is going there, but in the plant there is a location is different. So one here, one there, one second one there, but there one module I have installed in the lust, but there is a some of 18 or 19 location is there. But here in the central room, we cannot see there, because line of sight distance is very much required here to communicate up to the 2 kilometer or 1 kilometer. So antenna to antenna, not the module. So module we can install here. You can put the antenna is the outside in the top of the roof. So directly communicate to the antenna, antenna is okay. So communication will be okay. And what I am saying, that is a different location, but that is not mandatory to, from control room to this last module to see and line of sight distance is clear. That is not necessary, because if you see here one module, if you see here on installing one module here and there, and control room is here, if that one is near to there or that one is near to there from the control room, so from here receive the signal through this way, because frequency hopping signal technology working in this trusted wireless. What is the frequency hopping signal? Means one frequency here to jump there and jump there. Which one is near? So auto sequencing is activated in the module itself. Which one is near to this? Just I am giving one video, so it will be very much. Sound আসছে না হয়ে গেছে আমার এটাই জাস্ট
Radio line from Phoenix Contact. Wireless transmission of your I/O signals into your system with only one turn. The special features: easy startup of wireless networks thanks to I/O mapping. Assignment of inputs and outputs takes place easily via a thumb wheel directly on the module, completely without programming. Radio line is suitable for various different application cases, from the simple point-to-point connection up to complex networks, and transmits serial data as well as analog and digital signals with the latest trusted wireless technology. Reliable wireless transmission with radio line from Phoenix Contact.
So this is like we are already seen in this video. So some of remote application, so where we can taking the data from the wireless, so that is also. possible. And this is one example I have given, which I have already told. So from remote location to the control room is a secure data if you require. So one side modem and one side firewall. If you install, those communication will be the secure with this VPN tunnel. And this is the one, the GSM technology sending the data to the control room. Already I have explained. So different location you have a modem. So you can directly got the internet to this modem controller and sending the data to the internet and firewall if you install. So it can be the cloud-based solution or dashboard-based or in the physical SCADA also. It's possible. Like one example is the the data capturing from the like a motor to the vibration and all the data and the real-time data capturing. And this controller have a I/O card also you can the site installed. And IoT framework you can use this controller like a dashboard is inbuilt in our website. So you can just install this dashboard in your computer and connect to this internet to our controller and the all the trend and all these things you can see. Machine learning, if you require, so it is also there is a library you can use this machine learning. Artificial intelligence also we have, so that can install in there in this controller. And any type of MATLAB application also you can do this programming for your lab or here you are using the MATLAB. So MATLAB also supports this our controller. So this is the one example, the serial controller, serial data communication, energy meter data, or any type of Ethernet data. And the Rockwell have a Ethernet IP also. So that has also, we have a inbuilt protocol that collect the data from Rockwell, the Ethernet IP. So that is the IoT framework, our controller works as a sending the data to the cloud or any type of physical server. So this is the MATLAB application which I have Simulink, the MATLAB Simulink, which is very much familiar to our UVM college students. So that also you can use through our controller. Like one example I have seen that energy management systems, which are very much now required in the industry. So there is a different location, the SAP VCV is there, circuit breaker, and from there, if you have an optical fiber, you can directly connect to our switches also, optical fiber converter also we have in our product basket, energy meter also, the Profibus, Modbus, Profinet connection also in our basket. So no need to go anywhere. So all the equipments, all the components, all the controller and the service support teams also we have in our Phoenix. So like energy management systems, there is the data, capturing the data from the energy meter, and the IoT DAC, it is our controller, Axoline series, and the real-time data you are sending, monitoring and reporting purpose also. So dashboard based, if you require dashboard based, so you can open the any browser and taking the data and see the real time on if you store the data, so that also the possible. Like this one, you can see one of the example I've given there here. So real-time instincts, any type, anywhere, because you have a connection on this internet. So anywhere in the world, you can open your browser in the mobile or in your laptop. So you can connect to our controller and see the total real-time data. So, okay. And 5 minutes or 10 minutes or which one? Complete this one? Just 2-3 minutes. So এটা পরে আছে না এটা আগে আছে পরে আছে তো হ্যাঁ সো হ্যাঁ ওকে প্লিজ devices. So you can say the every equipment have a failure report. Okay. Yeah. Ratio you can say that at least one product if you use up to 10 to 15 years, nothing to do anything. Okay, so firmware or everything, if it's changed or it's a failure, is very less. Like 5,000, maybe one fell, I can say. So the depend on the batch, what is in production or it is normally. Because either it is in robust 70-degree temperature or minus 25-degree temperature it works. And the RAM is 8 MB RAM is involved. And the protocol, you no need to load any type of library there because it is inbuilt. So when we are using the FR2 case in this power transmission distribution, we program from here to this controller with the not the ladder or FBD because there is a configurator tool is there. So you can directly configure this controller also. No, cloud is not accessible means the communication path is there. So what there is our devices do not do anything because you have to secure the communication link. So active taking the data or report the data from our controller. So this is the device. So you have to secure the connectivity to sending the data, any type of Azure or AWS. Because if connection is failed, then nothing to do. No, firmware is, we are not required any upgradation of this firmware. Sometimes after 5 years, maybe new firmware is coming. So you can remotely update this one. Embedded.
Like your MPLS, ILL, broadband, any kind of communication if you use, that has to be ensured that that is working properly because that is your baseline. And you can put in your data to any of the cloud service provider, but still today communication is the most important thing to communicate from your on-prem to the cloud so that the security is one concern, availability is one concern, and the reliability also the one concern. So today we are discussing on that OT, IT, convergence, OT security. These are very, very important things in the student's life, those who are working and looking for that area to explore yourself in future. But thing is that this is, as the Soto said, that this is the combined thing. Now we are not looking for this IT is the different thing, OT is the different thing. It's a combined thing. If you are working in any manufacturing organization, then this is the most important thing to convergence and security for both the verticals, IT and OT.
landing zone. I think I am audible. So, so this is how the globally people are thinking about getting redundancy of connectivity. So your organization need to also have to plan redundancy because in current scenario, suppose any organization is having their centralized ERP like SAP or something else, and if you don't have a connectivity.
Thank you. You have any questions?
See, there is two things. One is that your business continuity plan, another is your disaster plan. These are the two very important things there. See, there is two things. Number one is that in your security, whatever the connectivity between your on-prem to cloud, that connectivity should be very secure. That you have to ensure from your service providers and all. And you have to understand what kind of technology are being used, what type of encryptions are there. So this is the connectivity, and that has to be secured. This is number one. Number two is that we all are sitting over in that on-prem. We are having the connected our manufacturing units and all, but our data is residing to the cloud. So it is through the connectivity. Again, connectivity should be there, backup connectivity should be there, because if today one connectivity gets down, the another connectivity should work, because your business should not be hampered, and your communication channel should be available at every time 24/7. So that whatever that IoT device, whatever your factory is, whatever the data is being generated, that would be properly saved to your cloud. So that you have to ensure that. So your question is very valid question. The DR, BCP, those are related with your redundancy and backup of your infrastructure. That would be definitely available. Even suppose you are working with one cloud service provider, you also look for the multiple cloud service provider, because some things you are residing to your primary cloud one, suppose AWS. The backup should be available in the Azure, GCP, any other service provider. If anything is down, at least you can get backup from the other service provider. In a different specific zone also, definitely, because once you do the compliance and audit all these things, so your primary location should not have your secondary location. Both should be the different separate zone, both should be the different availability zone. So these are the areas are there that has to be explored at the time of the negotiation and the vendor management, and on that specific your requirement as well.
So why different seismic zone? In case of any natural calamity, if you are in a seismic zone, it's not actually happens in all the
as well. So our next speaker, Mr. Kallul Dhot Choudhury from Rockwell Automation. So I request Mr. Kallul Choudhury to start his speech. Let's see.
Hi everyone. Good morning, and first of all I thank you Logarithm for arranging this seminar, and I always will thank UAM to provide this logistics and giving all this facility to use that, and along with that I will thank Phoenix for connecting with them and giving some of the industry thought leadership, because you are also one of the vendor who are working in this area, and from Rockwell Automation also. So just I give you some of the background. What is this workshop about? So morning that CAC person, he was telling me, you give some knowledge about PLC, RTU, okay. So what I understand nowadays, you people knows that. Even the college student, you know what is PLC, RTU, what is automation. But this workshop is about data-driven manufacturing. So let's set the bench first. What we are going to discuss. Now we are in Industry 4.0 scenario. What is Industry 4.0? Any idea, your college students, you know what is Industry 4.0? Why it is 4.0, first of all? Many of people, you people don't know maybe. So give a just short example. The industrialization started in Europe. That was industrialization, steam engine invention, and that was the industrialization started. Then came Industry 1.0. What was that? Pneumatic-based automation. Okay, a lot of, even in our young age also, we have not seen that. Maybe our previous generation has seen that. That is Industry 1.0. Then came electrical automation. It was contractor, relay-based automation. Okay, that was Industry 2.0. Then came PLCs, RTU, what Phoenix people is also talking, we are also talking, everyone is talking, we know that. That was Industry 3.0 when automation adaptation happened in the industry. Manpower reduction happened, people have some comprehension, but ultimate, it shows that it was not a manpower reduction. Ultimate, skill manpower demand increases. So engineering people, that all what you are studying now, microwave service, learning, VLSI technology, all these came at that Industry 3.0. So we have microwave service, chip-based solutions, controller, edge devices, all these started coming. Now in an era of Industry 4.0, what is that? Now we all talk about data. Whatever you are doing, everything is now data. So in manufacturing industry also, in Industry 3.0, it was generating lot of data. But that time only one device was there, if you know that, that was called historian. So we are logging those time series data in a server and doing some manual reporting on Excel-based reporting, which was very much in static nature, okay. It is a little bit background story if I give you, you'll understand how it came, data-driven manufacturing. So it was a static, so in any plant morning meeting, Monday morning, the plant operation head or plant head is asking for the production report. Before that, people is running with their Excel printout. So this done, OE, machine OE, this was the OE, this is the production, this is the downtime, these are the manpower, all are manual data, static data. You can manipulate, but gathering those data, they need last weekend work rigorously. Still there will be some fault because those are manual data taken from the system, from historian system, manual logbook, your attendance system, all various isolated silos of data collected manually, put in a Excel, put a beautiful chart, and then they will present. Now what you will do? Now these data are so frequently available. It was a need of the moment. There should be a evolution where all these digital data will help the plant manager or anyone, even the operator also, how his manufacturing is going to happen. That data will tell you, and it will be, your decision will be driven by the data. For that, you need such a system where IT, OT convergence. Why it came? OT is your automation system that we have used in Industry 3.0. Now those data are available in your IT platform, and dynamically, instead of putting some bar chart in Excel and all these things, now you have JSON view and lot of web viewing application where you do all those live demos, live dashboard. In the meeting itself, it is available. No one need to take any Excel printout. No one can do any data manipulation. It is just collecting from the system, presenting, and based on role. Suppose he is MD of the company and he is the production manager. His role is different, his lookout is different, his lookout will be different. There is another maintenance guy. He wants to know what was the downtime. He wants to know what was the production. So based on role-based, that will be presented to that person. So that is data-driven manufacturing. That is Industry 4.0. We are running in this area. Okay, so all who are coming out from the college, you should have this clear in mind. Industry 4.0 will not run if there is no Industry 3.0 or 2. But it is a data-driven. So data will help you accelerate your manufacturing, will help you take decisions, and that will be also be role-based. Whatever is your role, based on that it will be published to you. If you can do that in your industry, industry people are also there, and they all are IT guys, they know it very well. So if you can do that, your management actually looking for that only, okay? So before going that, let me introduce myself. I am Kallol Dhar Chaudhuri. I am working for Rockwell. This tenure is almost 13 years, and I have a total of 25 years of experience. Earlier I was in project commissioning, plant implementation. From that field I switched to the sales and marketing. And today I have two more colleagues. So they will also present some of the demo and some of the concept. So what we'll discuss today, all majority on the concept. So you understand the concept, if you have detailed question, you can connect us back anytime in the gap or at the end, we can discuss. But only we'll talk about concept, right? Anytime, anything in your mind, you can raise your hand and you can ask. So just going in detail, a short brief about our organization, Rockwell Automation. 24, it was almost $8.3 billion organization. And in India, we are almost 45 of years of presence, 47 now. And globally, it is more than 100 years. Precisely speaking, it is 122 years we are in there. And almost it is spreaded across the world, even almost all corners of the world, you can find a presence of Rockwell. And we work with lot of our partner and ecosystem. We have a lot of strategic tie-ups like Microsoft, Cisco's, even Finis is also one of our Encompass partner. So we develop technology in joint collaboration based on the industry demand, based on the market demand. Okay. So if we see by region-wise, North America is the largest region, okay, and now APAC level, Asia Pacific is the second largest, and which is catching up very high. You know why? Because of China and India and Southeast Asia also contributing on that. And by industry-wise, if you can see, we have basically categorized on three industry: hybrid, discrete, and process, almost equal share. And if you go by the segment-wise, we have three kind of business segment. One is life cycle services business, where from end to end, product to solution to service, we give that. There is another called product business, where we supply our hardware and software to the partners. They implement in their field. And there is a pure software business, where people use our software based on their hardware. So we always believe on a platform solution. So you should not be bind to any particular product, any particular vendor. Everything should be open. So just this remind me one of the story. When earlier I was in Emerson, that time Emerson was selling too much on foundation fieldwork in industry. You know foundation fieldwork. That time, don't take mind it. I'm not criticizing any company or organization, but this is a thought. That time some organization was talking about Poppy bus, some was talking about Modbus. That time our CEO told future would be Ethernet. So people are saying why? Why Ethernet? Because Ethernet is such a protocol, it is really open in nature and it is not a proprietary. Because in future, not future, now it is present actually. If you have to connect multiple devices from multiple vendors. So there should be one common protocol. No proprietary protocol can restrict you. If it restricts, whoever from the industry, you know what is the pain. Then you have to put converter, many other things. And your option will be restricted. So Ethernet, we adopted, like our partner ENH also adopted their instruments on Ethernet. So nowadays you see almost all vendors having their devices on Ethernet, on wireless, on Ethernet, TCP/IP especially, not the proprietary Ethernet I am talking about, so that it can be connected. So just a thing. So let me show you what is the digital factory. So first I will show you some slides, then I have a video. I will not bore you. Okay, so that video will show how our digital factory should like, how it will operate, and what the benefit you can get. So first theory. So you can see there. So this is a little bit of Rockwell part of it. We have two portfolio mainly. Our hardware portfolio we call Logics, and the software portfolio, thank you. And the software portfolio you can see that we call it Factory Talk, and this is integratedly connected. And ultimate, it is leading to our Industry 4.0 journey. So these all put club together and it is going. So here we have all kind of solutions. So I'm not, because there are a lot of things to show you. So how connected is your manufacturing, or what is smart manufacturing? So this is the present scenario of your plant. Who are from the industry, you know it very well. There is many isolated system and demands, and those are layer-wise. You can see data layer, management layer, ERP layer. Below is the production layer, where you can see the OE, SPC. So what I was telling, role-based. So who are running the plant operation, their role is there. But their management level, they are sitting over here. So all data, whatever to be presented, that should be role-based. What role you are working. Otherwise, there is no meaning. If the company CEO is interested on this part, no. He's interested on this part. Operators, they need based. So all these silos and data need to be connection or whatever way, but it should come on a platform. That's why common protocol like Ethernet, what I was talking, or wireless Ethernet, that need to be implemented. Okay. So this is some of the key Industry 4.0 pillars. So if you go there, you can see there is smart rapid product development is happening. And then there is a resource optimization requirement is there. Then there is manufacturing simulation is required. These are the some of the, you can say, component of Industry 4.0. Industry 4.0 does not mean a common solution. Based on your requirement, you can pick and choose. It's not only from Rockwell, from anyone. You think in actually you require this solution. Suppose you have a process plant. So process control optimization. Industry 3.0, we had DCS, we had batch system, we had continuous process system. That was the process control. Now in Industry 4.0, we'll call on that optimization of that process. So in your existing asset, how you can produce more, that is the demand. If your technology is not helping that, then there is no meaning, no fun. Why to invest on the technology if it is not helping you producing more? So that is the market demand. It's not Rockwell or we are talking. This is the demand from our customer. Okay. Same way, digital performance management. Initially, I told you, no Excel pie chart, all this. There should be a dynamic dashboard pop-up based on your role. And from there, you can understand what are the pain areas, what are the problem areas, and you can take decision. So data-driven decision. It's not from something your mind or your guts feeling. Earlier, plant was operated by guts feeling. So it should be more on the data-driven, not guts feeling, proven, so that your decision will be quick, fast, and it will be result-oriented. Asset performance management is one of that. Then energy management. So this is the most important part. Nowadays, you know, global warming, what is happening. No need to tell anyone. You people student, you know that. Everyday news it is coming. Somewhere flash fire, somewhere heat. In desert area it is raining like anything. So there is a big drive from globally. Manufacturing should be more greener. How to do that? Earlier days, I remember when our career started, that time we used to talk, use VFD, variable frequency drive, that will save energy. Nowadays, that is very small part. Many of my customers says, I've already installed VFDs. What else? How I can optimize my energy? So these digital solutions, they are there where you can use, optimize more. And it can be, payment can be linked up with the optimization also. How many units of current consumption you are reducing? Based on that also, that can be calculated. Okay, so this is most important, and the recyclation and all, everything is not only energy, the full supply chain. That's, you know about series study, I'm not going that much detail here. So those are important, and those are the demand of the current time. And then last part, augmented operation. What is that? A small example. Suppose today there is one operator, new operator joins. They are sitting there, they joins in a plant. They have not seen those machines. And there is one guy who has 30 years of working experience. He knows machine like anything, but he is retiring. 40 years, he is retiring. A new person came. So again, that training, less skill manpower. So why it is required augmented operation? It will help him a real life training without having that experience. Even there is a possibility, I am not going on those products, we have those kind of solutions, not only we, many of our PR competition also has those kind of product where a experienced operator can operate a machine, this is a machine, he can operate and do a video recording and it will be there in the system. Anyone new person came, that will be guided through HoloLens, it will guide him to operate that machine, maintain that machine. Okay, so those are the augmented operation. So too complicated slide, skip, because I have something more interesting. Now this is one interesting part. This digital journey, Industry 4.0 journey, is not so simple. A lot of questions, lot of confusion will be there because there is a silos and on fine day you cannot bring all silos in the same platform. So it has to be a step approach from static manual to going to self-organized dynamic demand-driven operation is not a very easy journey. For that you have to walk many way, many path. You have to work on your operational technology, your information technology, IT people are there, you know that. You have to have a robust IT policy, IT technology, data analytics, your process people, your production people will say what kind of analytics they want. Then your process management system. Most important, when we talk about why most IoT 4.0 projects or initiative fails, because of this workforce. Because IoT 4.0 or data-driven manufacturing talks about human and machine interaction. So if human workforce are not trained for that digital manufacturing, it is bound to fail. Okay, so that's why if you see nowadays, adoption of that technology, that is the most important. So this is the most important. So you can see Rockwell, earlier it was listen, think, solve. Now we say human possibilities. If you can think something, those are young mind, they can think, they can build apps. So this is workforce adaptability, training. So that is the most important. So any of our customers, when they adopt something on Industry 4.0, they think we should implement this solution. We first say, you do a change management workshop. Without that, it is not possible. You first train your operator, because the operator understand that they will take the mouse, click that motor, click start, stop, they knows that. But how to operate this digital journey? So they need that, you know, there is a now digital logbook. Earlier, people used to take books, keep that data, time, this. Now, one fine day, you implemented a digital logbook technology. Okay, many of we also have, and our partners also have those technology. You give that to operator, this is a tab, oh, one fine morning he said, no pen or book, they are tab. So what I have to do? I use Facebook, WhatsApp in this tab. Now I have to record data in this tab. So that workforce training is required. Automation, anyway it is required. So ultimate, now we are telling that autonomous automation. So earlier it was automation, now autonomous automation. What is that? Automation system should be more adaptive. It should learn, it should self-implement. If you depend everything on the operator, human error will come, there will be a delay. If some part, some area you can do autonomy, the machine can learn and implement, that is autonomous automation. Then most important part, you do everything, you forget this. One fine day, some competitor came and do something. Big houses already face lot of trouble because of that. Russian people, hackers sitting there, targeting American factories, industries, let them down. So this is not a sci-fi movie now. This is a real challenge nowadays industry facing. You all IT people, I need not to say you people, you know it very well how much challenge it is now. Still some people think, oh, security, yes, I'll put a firewall, done. these young engineers, you give them a firewall, maybe 1 hour, 2 hours, someone take 30 minutes, they'll break that. Very easy, not very challenging, okay? So putting a firewall only and all those things will not solve your problem. So most critical part, security. Okay, we'll little bit talk. Devas is from our metal industry business owner. He is actually working on that. He will tell you something on that security part. So that's it. After that, I will run a small video. First, let me tell you, so we had one presentation of this, but I want to run this video. You will understand how future or maybe some of the current plant, how they are operating their factories, okay? So what is actually smart factories or data-driven manufacturing? So that you will see here. This is a demo. We have not taken the real customer name because of that confidential, you understand. This is one of the battery manufacturer in North America. It has implemented and it is running there. With their permission, removing their name, but data are a little bit real.
Welcome to RA Battery, a demo that is powered by Factory Talk Innovation Suite. Today I would like to give you an overview of our state-of-the-art Innovation Suite platform and how it can enable battery customers from an executive to the plant floor level and help optimize manufacturing operations. RA Battery is a fictitious global battery manufacturer created for the purpose of this demo. It has 15 plant facilities located throughout the Americas, Europe, and the Asia Pacific. John Casher is the Vice President Manufacturing and Operations with global responsibility. From this enterprise view, John and his team can monitor the daily production KPIs of their enterprise. You can review the battery production, scrap, fuel efficiency, OEE, and the first pass yield. As you look out at the enterprise view, you can see that the OEE is falling as well as the production units, a warning sign to review the raw material management as well as the asset utilization. So we would want to investigate what plants are causing this. We can go to the all plant performance. As you look out at the enterprise.
Before moving forward, what I was telling you, earlier it was a Excel based report, okay? Now this is kind of a live dashboard. So they have multiple plant in various geographic location, one multinational company, and these are the geographical location. Overall, their OE, plan, process, these all data, these are dynamic data available. If he can click on particular plant, he can see what are their data. And he can drill down on those data. His next part, they will drill down on a particular site. Okay. Backend, this is not so easy to come at this stage. There are a lot of security, integration need to happen, connectivity, all these things required. But it is available and it is a role based. So he is one person based on his role, this VP, he can see those data only. It is not available to anyone.
Price view, you can see that the OEE is falling as well as the production units, a warning sign to review the raw material management as well as the asset utilization. So we would want to investigate what plants are causing this. We can go to the all plant performance to see the status. And here we see that Seoul plant is having a higher amount of scrap rate. From here we can navigate to the Seoul plant and see what is going on. We can clearly see that Seoul plant is having some issues with the OEE as well as the production units going.
So this is the power of data. When he clicked on the Seoul plant, he see OEE is a red alert. There is 47%, there is a dipping. And there is a dipping on the production also because of that OEs. So this is the power of data. it will help him to take that. Then he can drill down what is the problem, why OE, or he can talk to that plant manager. Then he will drill down in his dashboard and he will find out. In the same way, it will percolate to below. Data are available. Just you can understand this plant having problem, why problem, analyze, rectify, come back.
Down. John might want to reach out to MJ Lee, who is the plant manager, to check the OE related issues.
He's sending message from the platform.
MJ can take charge and jump into the plant overview screen to see what is going on.
Now the person change, role change. The engineer now is seeing his dashboard. This is not to the MD or VP of the operation, okay? Because he sees fuel plant, OE down, production down. Why? He put a message and the engineer now he is seeing his own plant dashboard, okay?
From here, we see that our plant-specific KPIs are up top and area-specific KPIs are on the left, giving additional indicators on our process. As we look at our overall plant view, we can see various
Alerts.
faults and warnings
Problem
in the
areas it is giving.
The complete plant is divided into the electrode process area, cell assembly, and the cell activation process.
So 3 areas of the plant.
Let's go deep into the cell activation process to see the area in detail. As we look into the cell activation area, there is a red fault icon in the formation line. This indicates about a problem that we should look into. As we dial into the cell activation area, we can see the downtime by duration and the occurrence, and we see that formation line number 2 is leading the chart.
Here one interesting thing, if you can see in detail, it is not there available. Downtime by duration, I did it from here, it is not so visible here. Downtime by duration, downtime by operation, restart reason and scrap reason. So which fault is staying more and which fault is coming more, frequency. So one is time, another is frequency. Based on that he can decide actually this is contributing to the down of the OE. So this is the power of data. Using this data he can reap. So in the bar diagram, it is nothing coming out from their historian system. It is nothing new. It was there earlier also, it was there. Historian we are using for last many years. But now it is coming on the dashboard live by frequency, by time. So we can decide which is contributing more. You can act on those areas. Earlier, you people know, some old people, you know that long time series data, you have to search when it has stopped, why it has stopped manually. Now it is at a glance, it is giving you. So more quickly you can attack your pain point.
Both in downtime by duration as well as by occurrence. There are various restart reasons for the line, such as the cell orientation fault or the pin contact fault, and also some scrap reasons such as cell short circuit fault, high discharge rate, or high charging rate.
Even individual, what are the scrap region, which is contributing more, everything available. Earlier also it was available. Now the way it is presenting, the easily it is accessible, that is the key. That is the data-driven manufacturing. It's not like that now this data is coming. It was there long back also. In old industry also it was available. In other way, now it is more contextualized based on your role and based on your requirement. It is actually showing you. So only getting lots of flooded data is not a key thing. It has to be contextualized. Then only you can understand those data. Okay.
We can go one more level deeper to see that line number 2 is having issues with the cells not being able to charge to the required capacity within the required time. And also there are non-uniform variations in the discharge rates of the cells. Clearly indicates a problem in line number 2 in the formation area. We can go a level deeper in to track the genealogy of the battery cells that are being tracked for their performance state in each of the formation line probe units. We can clearly see that formation line number 2.
You see, earlier also this data available. Now each production probe unit, which are the red dot areas, it is directly pinpointing. So those are the problems. Those are the problems. He can see at a glance.
Has high number of cells showing the status as not okay. We have got couple of actions to decide based on the cell parameters. We can either raise a maintenance work order for the maintenance folks to debug the issue.
Now he is creating work order from there, from the same platform.
Or we can also mark some of the cells as check for the quality team to decide the physical, decide based on the physical status of the cell whether to scrap or whether to rework the cell. This makes it a closed loop process to track and resolve the issues identified. Hope you enjoyed watching this video. Have a good day.
So this is the way. That is called data-driven manufacturing. So that VP operation has seized this plant, this problem. He put a message to the plant head gone deeper in the cell, which area. He see the detail chart report that he found the problem. He generated the work order for his team. It can be for maintenance team. It can be for third party buying is required for the procurement team. He can send that also from the same platform. So that is called data-driven manufacturing, and today's workshop is about that. So with that, I end my things now, and you can continue.
Thanks, Mr. Kaulul Chaudhary, for his nice lecture. I think you all have at least an idea about what way IoT work, industrial IoT work. Once again, I ask you, everybody, if you have any questions regarding this presentation right now and what you have seen before that, if you have any questions, or security or IT, any from any divisions, many persons are here. So if you have any questions from the student group, if you have any questions, student group, no questions? Okay. So you are a little bit shaky for this. Anyway, right now, we have a question in turn. Since you have no question, we have a question. Okay? So what we have presented by Phoenix, by Rockwell, so we have a short questions. Just I am throwing to you, and there is a spot gift. Who will be the winner for that question? So please come here. Our diary ta kotha rakho? Everybody, get ready for the question. The question is from the Phoenix product. From the Phoenix product, Phoenix presentation we have seen. From the Phoenix product, the next gen PLC technique has a very special characteristics, very special property. Next gen PLC. has a very special property in terms of protocol. What type of protocol the next gen PLC have? Anybody else? Huh? Once again, next gen PLC, PLC next, as a protocol that we have shown in our presentation. What type of protocol? All protocol means open protocol. Thank you. Please stand up and come. Big applause for him. Thank you. Your name, please? Sudhanshu Goel. You are from? Hindalco. Please take your seat. So thank you. So this is a short quiz session. This is over right now. So we have a short tea break for 5 or 10 minutes. After that, our next speaker will come. We can continue. We can continue. Okay. Please take your tea. The next speaker, Shubhrojit. Mr. Shubhrojit Das, please come for his next speech, which is storage and analysis of IIoT data with edge gateway and predictive maintenance. After this quiz, we have another, after this speech, we have another quiz, which is quiz 2. So let's proceed and hear it very carefully. Over to Mr. Shubhrojit.
Hello. So I can start. So now come to the point in the storage and analysis of the IoT data with the edge gateway. So already we have talked about the edge gateway, controller and all these things. And from Rockwell Automation, Kalula also told that the devices interact with the Rockwell systems and any other third-party systems in our gateway to taking the data also. So now the data is coming from the field that I have already discussed. And now the storage is required for the data analysis and driving part to this data, the anomaly detection of this data, visualization of the data. So storage is required. So data coming from the field through any type of Ddm-Iiot, AI, AO, serial, any type of data. And from there, the data coming to our controller. And from the controller, we are sending the data to the local devices, local server, or any type of cloud where the storage systems is available. So here, we can see the one block diagram. There is a secure edge box. There is a one storage box or any type of server or any type of cloud IoT framework. The data is coming and the store is their hard disks. From there, you can directly broadcast the data through the web-based publishing. Web-based publishing means there is any type of Google, Microsoft Edge, or Opera, or Firefox, or Mozilla. You can open the browser, and there you directly put the IP or API to taking the data from this storage section. So data is storage in there, and from there you are broadcasting to the any worldwide platform through the web base. Because in the mobile you can see this data, you can in computer you can see the data. So the data storage is required. Why? Because you have real-time data and the storage data, means the historical data you require to the anomaly detection, to the predictive maintenance of the machine, predictive maintenance of the motor. So you require the storage data. Because the real-time data, when you open the browser or just see the data, the trend, but ultimately if you close the browser, then the data is gone. So you require to store this data to this predictive maintenance or anomaly detection. So that's why data storage is required. So storage, there is a 2-3 type of storage we can see. Here one is our visualization software. You can open the browser at, I have told, the any type of browser, or the standalone base in the plant level where the SCADA installation also is there. So our SCADA name is Visu Plus. That also we can install in the local peripheral, and from there you can store the data, or any hard disk with a high level language scripting you can store the data. So there is a one block diagram, there is one machine, so we can see from the web browser and also our SCADA part. Our controller have a facility to show the data or to transfer the data through the web base or in the physical server as a SCADA based solution. So there is a web based visualization and SCADA based visualization, both are possible. Also the OPC is one of the most protocol where open protocol, the OPC, we can send the data from one SCADA to the another SCADA, one SCADA to another, any third party, Siemens, Rockwell, or any type of their SCADA, also through the OPC gateway, we can send the actual tag. So we can say the connectivity of this SCADA, Happy OPC UA, any type of code assist, Omron, backnet, so BMS solution, the backnet also is Siemens. So all the protocol conversion, it is inbuilt in our Visu Plus, because there is no need to install any third-party driver there. 61850, the FR2 solution also, there is a library function is inbuilt in our SCADA. So like meters we are taking from the field level to our edge controller. And from this controller, we can see the real-time data, and this data we can store also in the IoT framework. From there, we export this data. If you require any CSV file, that is also possible. If you require any MySQL or SQL to store the data, the Oracle, you can store the data, that also possible. From there, no need to do anything. The script is inbuilt. So you have to drag and drop the script, and you can export the data, whichever is required. Because if you need the 3 months, 6 months, 1 year, 3 years data for this motor, for the how it is working, or what is the temperature is going, the bearing temperature, vibration is monitoring. So all you can see from this storage data. And this is for the dashboard base or the real-time SCADA base. From here, the data is storing, the reporting also possible, and now the ML next. So machine learning, you can script any type of your customizable board. Means the some of requirement we need a 3-month data, but the motor vibration we will see how it is increased, what time. So that is also possible. To machine learning model also inbuilt. So only you have to drag and drop this library, this function in your cloud-based or any web-based solution, and from there you can predict that the motor, if it is running in 24 hours, so on the 12 hour, so motor vibration is increasing their set point. That also you can predict. Okay, so last 10 hours the motor was that in load, and coming 3 hours or coming 5 hours, that can be changed because of this production rate is increasing. So that also you can predict. Here the on the dashboard where the notification also come, the trend also come, the alarming also come, and there is a set point limit you have fixed. This is the vibration set point is there, temperature set point is there. But when you shoot this set point, so automatically data alarming one pop-up will come in your browser. Or there is a mobile-based solution. If you trigger the mobile SMS or the mail SMS, that also possible. So one mail will come to the hierarchy level. If you set, there's a 10 numbers of hierarchy that this motor is a very critical, and this time it will overshoot this. So that also we can predict. Normal flow diagram, if I see that there is a machine, so machine is action by the soft floor level engineer, operator. So that is for the maintenance point of view, they are maintaining the machine. But we don't know if the operator start the machine and sometimes the machine is running, but there is no production, and the operator go for the lunch and coming the delay for 1 hour or 2 hours, but machine is running. So you can predict that the machine is running, but the continuous curve, the machine production is not as per the limit. So you can predict that machine is running, but maybe the load is not there in this machine. So there is a sensor data is coming to our main controller, H. There we are storing the data. From there, we are reporting that this time the machine was load like a 20 ton per hour. But during the lunch time, maybe 30 minutes or 1 hour, so machine should be 0 ton per hour. And after that, 2 p.m. or 3 p.m., so machine should be run in 20 ton per hour. But there is a lag for the 3 hours or 2 hours. So continuously it was 0. So we can predict that from these data sets, that the report that the machine is not working on that time. So this is the function already we can implement in our dashboard. We can implement in the local server also. And now for this predictive maintenance, we can machine health position. Also it is in very, we can predict that the machine condition and the level of the water level or some of wearing temperature, vibration temperature. So how it is going on, the winding temperature, how it is. So we can see the total data. Whenever you want, you can open or you can see, because already you have stored the data. From there it is pulling and broadcasting to your mobile or your computer or laptop. Now for this predictive maintenance, so Industry 4.0 already Kallala told, so that is already, I have placed one slides, so it was the same thing he was told, that 1.0, 2.0 and 3.0 and 4.0, maybe it was 0 or maybe 0. So present scenario, so data is very much required with the secure data, and sometimes what to do, that the data coming from field, that is okay, but that not the garbage data, that has to be secure, because the depending on the data, you can calculate the production rate, increasing the manufacturing good quality, increasing the valuable product, and the time limit also you can see from that data. So quality demand as per the increasing valuable variance product, or if one operator is running with one machine, but actual data which is required, that is not coming. So that we can see from the Industry 4.0. So main things in this data-driven IIoT platform, so data. So data collection is one most required, that we have a different type of products. From data we can collect, every data. So we can collect through our devices. So that is we have in our Phoenix basket. And now that data normalize and store in one location. So that may be cloud, maybe physical. And that need to be analyzed. Actual data which is coming, that is not the garbage, that is the good data. And on that data, we will analyze that data. So that is the main three things we can propose the Industry 4.0 solution to the industry. So, so there is this machine learning, one is the scripting. So if you, actually data is coming some of interval, like a 1 second, like a milliseconds, like a 250 milliseconds. So you are taking the data from the field, okay? So sometimes your communication is break somehow, okay? Ethernet switch problem, maybe Ethernet. So there is a sum of zero data or garbage data you will receive. That like a 999.9999. So that, but previous data was 10.25. Next data 11.25. So that means that data is the garbage data. So we have to normalize the data. So machine learning wants a script that has a internal compatibility to check actual data or this is garbage data. Okay, so that is the normalization. So now the application requirement were the main, you are on the SAP, SAP, or you are on the upper level, the application layer. But the data is in the zero layer, the field level. So field level to the application level, there is so much protocol is there. So how the data is the digital format or analog format. But the application layer, it is in normal. You can just see the ASCII data to conversion the high level language, or normal digital analog data to the high level language. So this conversion is required. So machine don't know the high level languages. So they cannot publish that. So for that case, between that, so we have a gateway on this edge gateway. There is a compatible to communicate the machine and the higher level application layer. So that way we are using there our product, where the machine sending the data on the field level data and high level language data when the computer knows, so that is converting. So that is the database. If you use the Oracle, if you use the MySQL, SQL, everywhere we can set this data. So one more example, like a energy meter is there, some of the field devices is there in the lower level. And there may be one Profibus communication, maybe the Ethernet IP communication, maybe there is a Profinet communication, or maybe the DNP3 communication or MQTT. So there is a different protocol in industry running. And from there, we have a device that can directly transfer this protocol to the single protocol, like Ethernet, if you're the Profinet. So you just connect to the switch, to the computer, so you can take the data to this single protocol. So no need to install any third-party protocol to your computer to see actual energy meter data or actual sensor data, because there is a different. One is communicating to the DNP3, one is communicating to the Modbus RTU, one is communicating to the Profibus. So how many protocols are you installed in our computer? So no need to do, because all the compatible protocol conversion is there. So that is the key product we can say in the Phoenix USP. So today automation, there is a limitation, some of limitation, there like a cross-company integration of lagging for engineering effort. So HMI, you can put the note the data. So all the data you are taking the automatically. So why not? So that's why Industry 4.0 come. So this is one production architecture production level. There is one machine, there is the energy systems, ACB, BCB installs, grid, substation, there is infrastructure like a WTP, OHR is there, and there is a logistics also is there. So from there, all there, you have to take the data. So field level, the sensor, yes, we can use. But here, from the inside the machine, we have to use not the SIM base. It is not required. Why you will depend on the SIM? Because of towering problem inside there. So we can use the radio line product here. So for the energy systems, we have an energy meter, we have a Modbus RTU protocol, we can put it there in our Modbus type of devices there. In the far away, the infrastructure area, the WTP, so there is not linked with the maybe 10-kilometer distance, the WTP water is coming for this production. So there, we can install our SIM-based solution. Here in the logistics, we can use the normal LAN-based communication. So both these 4, 5, 6, 7 areas in the total plant, we can take the data, we can communicate the data through our different products, which in our Phoenix basket, there is all are available. So like this example, like a wireless LAN, Bluetooth. So there the robotic application on the car workshop or car production unit. There is some of robotic arms. There's a heavy, frequently movement. So there we have a devices on our colleague Subham also explained the power and Ethernet data also can communicate to this because robotic arms one and that is moving heavy wave is continuously moving, but the signal we cannot take through the cable because flexible cable is required or maybe sometimes the cut that's cable. So there we can install our devices, that is the near-fi technology devices. That also possible. So the heavy movement or frequently movement, we can use this data for the communication of the power and data both. So no need to require any 24-volt power to give these robotic arms. So not required. So we can transfer the power also. So here the machine is, one line is going there. So there IO-Link also, the new technology IO-Link instrument also is there. Some of IO-Link switches we have. So IO-Link devices we have, they directly communicate to the Profinet or they directly communicate to the Ethernet. So we can connect only there to M12 or M5 connector, the industry already you know that the connect the sensor or devices to this IO-Link and from there IO-Link to the Profinet or the upper layer, the application layer, the sending the data through the switches or their switches also in our basket. And from there, the gateway, if you need to conversion this data, then also we can use our controller. And smart switches where the optical fiber also required. So we have a switches that inbuilt optical fiber port, no need to install any fiber SFP module also. Because in the switches, the inbuilt SC or ST type port we have. So the switches also in our, and MR pairing switches, schema certification switches all. And firewall, obviously we have the mGuard, and from there, the factory level remote. So Profi Cloud is our Phoenix proprietary cloud, so we cannot tell customer to use this Profi Cloud because AWS is very much popular to any of the industry, Microsoft Azure, Google Cloud. So from there you can install. So no need to use the Profi Cloud. So you may use the Profi Cloud as you wish. So any type of third-party cloud also we can store, analyze, and from there we can publishing the data as a report. So one example, like with the storage and analyze the data. And from there, we can see the real-time data and the controlling data. And one more option from dashboard, you can open and close the valve also. This is the both a communication we can connect to your field level equipment as the IoT and the from central room anywhere in the world, you can open and close through this MQTT protocol or any type of different protocol. So this one is like an instrument. You are capturing the data from the RS-485 different location, and there is converting the data to the Profinet, and now the real-time data also you can see, or the physical server-based SCADA also you can see, and you need to send the data OPC UA, also the another browser or another SCADA, maybe Rockwell, maybe Siemens. So from there, OPC UA, you can send the data. And that data you can see also from our controller also, because our controller have a capability to take the real-time data also. So this is one normal challenges where we face taking the data and why we are using this Industry 4. So the field level, the production, the manpower less. So what to do? We have to take all type of data. Either anomaly detection is not possible, because if you predict some motor current or motor vibration or any type of coming, what to be next, you have to know. So you require the last 6 months minimum data, where you can analyze. So how it will affect after 1 month, after 1 week, or after 2 weeks. So motor health you can monitor from there, collecting the total data. So not only one data it is not possible, like a current or voltage. So we are taking only. So that is not possible to analyze the motor health monitoring. So you have to take the all type of data to actual benefit to this Industry 4.0. And also we have an option, so that a mobile messaging, or from mobile you can see, or from mobile you can operate also. So there are a lot of application we have done in this Calcutta also, the water, wastewater section. So there all the water section, the OHR all are deliver the water from different area, Action area, Salt Lake area. Here, if some pump is off, automatically message will come in your mobile. So this area pump is off, distribution is cut off. And from there, you can select the hierarchy level message to your higher authority. If you have a permission, so you can open that valve also, or you can monitor also for that data. So that is the mobile application also we have, whichever is possible. From there, you just directly go to the PLC next door. There, APK file or like a one installation file, you have to download this file and install in your mobile or in your computer and see what is exactly going on. And this actually help us to different location in the worldwide, in the pan India, in the outside India. So if you have a different location, have a plan, so all the data you can come, you can take the data from the different plant, and from there you can see the production rate. You can increase the production rate. That will help to the ROI of your production efficiency. So from there, this is a normal diagram. So that's all from my side. So if you have any questions, so you can. Okay.
Hello.
Hello. Mr. Shubhama Chakraborty of देखिए एक मिनट आप नहीं बोलो ना. Our next speaker will felicitate Mr. Shubhama Chakraborty, Chairman IEEE Thames, Kolkata chapter. I request Mr. Chakraborty to come into the dais. Please come. And felicitate Corbin? Okay. Please come. Please come. For your topic is about the workshop. So, Mr. Over to Shubhama Chakraborty for his speech.
I can use this. Good afternoon, everyone. So I don't want to hold your lunch. So just a quick hello to everyone. I am working in ABP as CTO, but here I am not as the CTO of ABP, but rather as representative of IEEE. I think Paul Lobda has already talked about what IEEE is. And IEEE Thames is one of the societies. There are many societies. So Thames is Technology and Engineering Management Society, which more or less kind of is in tune with all of us who are in corporate, who manages as well as handles technology. IEEE is one of the largest body. I think all of the students and those who have come with an engineering background, they will know what IEEE is. So my earnest request is please be member of IEEE, because we wanted to help Shotto to plan this program with IEEE credence. It makes a lot of pride for us to be associated with him, and I'm sure you will get some value out of the program. If you need to know anything about IEEE Thames, how to be a member, what are the benefits, we are happy to discuss about it, but we can discuss during lunch also. Thank you.
Thank you, Mr. Chakraborty, for your speech. Please wait. We will felicitate Mr. Chakraborty. And felicitation is given by our MD, Mr. Shotopriyo Das. Thank you. So we can start our next speech from Mr. Debashish Shorkar of Rockwell. I request Mr. Shorkar to come into the dais, please, for your speech. Now, his topic is IT and OT convergence. Please, over to Mr. Chakraborty.
You can carry on the quiz, no problem.
Okay, carry on the quiz. Okay. We have a quiz at this moment also. So can I carry out just a minute? It is an interactive session, so I will request all of the industry people from Hindalco, Star Cement and all, that you have traveled a long distance from Meghalaya to Calcutta, so you shouldn't be shy, you should speak, you can ask any questions if you have. हिंदी में बोलिए, कोई बात नहीं है, हिंदी में बोलिए ना, कोई बात तो कर लीजिए हम लोग के साथ, ठीक है? Anyway, तो the next quiz part, everybody is ready? The first quiz question is, we observe from the machine point of view, a very important factor of a machine to visualize the predictive maintenance of the machine. So what particular factor we observe under predictive maintenance? Data collection. Anybody else? Huh? Achha, abnormality. Anomality. You? Data analysis. Anybody from the student group? What factor we observe for a machine under predictive maintenance? Downtime. Madam, please. Anybody else? You? Temperature variation. Is it under the health performance of the machine? Temperature variation. Please come. Thank you. Great applause for the madam. Please come, and what is the big mug? Please come into the dais, please. Achha, your name, please, madam? Oopsie. You are from? Okay. Thank you. A big applause for madam. We'll go to the next phase of quiz. So before that, I request Mr. Sarkar, Debashish Sarkar, for his speech. Over to Debashish.
Thank you very much, sir. Thank you. Thank you, Logarithm, and thank you, UEM. And, it's a nice opportunity to have here. So, we talked about, we heard a lot of, in our previous sessions, data, analytics, everything, right? So, Mr. Kamal also mentioned that part, one critical aspect, and also someone asked us, very nice questions. So, we'll cover these same things here in this IT-OT convergence. That's a very important topic while we talk about the digital transformations. Okay, so already we started the topic before the presentation starts, right? So it's IT-OT convergence, which is very important part of our digital transformations. Okay, this I will skip because my colleague Kallol already covered. You probably know Rockwell Automation is now at this point of time. All the data silos, it could be operational technology data, it could be ERP, it could be your engineering data as well, PID, PNID, whatever you say. So everywhere the data are there. So once we bring all the data together, so that comes the connectivity all together. Okay, and now it comes as the convergence of information technologies, the operation technology, both the two worlds coming together. And so once these two technology comes together, it comes as a optimized architecture you need for the connectivity. It's not about only small PLCs, it's not SCADA, it's about everything. But when we connect, we try to connect all these things, we see now industry has a lot of challenge, okay, in terms of connectivity. You see lot of aging infrastructures. Like when I say aging infrastructure means lot of old PLCs, lot of old SCADA. You will see Windows XP, even Windows, DOS as well, okay. So once you try to connect, you see, lot of challenges, the vulnerability comes into picture. And because why the vulnerability comes into picture? Because now you have the visibility of the system. Earlier you did not have. So now, once this comes into picture, you think, okay, it's very simple job to do that. Is it so? No, because you need a OT team who should have the cyber skill. Normally it lies with your IT team, okay? and lot of regulatory pressures to the manufacturing industries also, because many organizations in India as well, some of the industries, there are bound to have the regulatory compliances, otherwise they have to fill lot of penalties. So once we connect to the OT system, it has to be safe, secure enough. And not only OT systems, once we talk about the full enterprise level digital transformation, we connect the supply chain as well. So once we connect the supply chain, it's an integrated supply chain. So if there is a security breach in one part of that portion, it actually creates a dent to the whole system. So that's why these are a lot of challenges. And once these challenges come, IT and OT. So, both are coming together. So for OT people, they have a different priority than ITs. Okay, you can correlate with that. For IT, it's about the data security, it's the IP protection. Okay, for the OT people, it's availability. That's the integrity, and then comes the confidentiality. But for IT, it's completely opposite. It is CIA, not AIC. So that's why that both of them have a cultural difference altogether. So now, so the security policies what we have in IT, can we deploy that in OT? It's very difficult. Okay, so you need a properly designed segmented network for your manufacturing industries. And here comes, what the best practice we follow to the other manufacturing industries is that, best approach is the National Institute of Science and Technology. They made a framework for a cyber security which is vendor agnostic, and it says that there should be a proper governance. There should be OT policies. It's about, we're talking about the OT security policies. There should be security policies and procedures. There should be some risk management strategy as well. And there will be roles and responsibilities to, inbuilt on the OT people and the IT people as together. So when comes, so there should be a proper governance. And the NIST framework says that first you identify what the vulnerability you have in your system. So for that, normally what we do a cyber risk assessment. We start with that, okay? And we do a vulnerability assessment, then we do a penetration testing, network assessment as well, and then external threat mapping. The threat can come from internal, it can come from external as well. Okay, it's not like always the external people come to your system. It may be internal threats as well. So that assessment is must. So that's the first step we do. And then we design the system in such a way, that's the protect. Once you design, we understand what the vulnerability is present in the system. You create or design the system in such a way that you mitigate the, you design the system in such a way that, no one from outside or from inside, can access that. So that's the, theoretical term. That means the probability of access get reduced. So that's why we create Ddm-Iiot, okay, and network segmentation. So, and it comes this remote secured access and OT patch management. IT patch management, OT patch management remains a little different, because when it comes to the OT team, they will not allow you to change the patch every day. Okay, so IT patch management, OT patch management is a little different. So that's why we have to be careful that OT people never allow, because they need that system to be up always. They will not allow you to reboot your system. Okay, so now once we protect the system, we design the system. Okay, now it comes, okay, I have designed the system. Is my system is cyber secured enough always? No, because there will be always trend from the outside world, from the inside threat, that they will come in to try to penetrate. Okay, so we have to detect. Okay, that is the intrusion detection. So you work with that also. So that can also be done. So so that is intrusion detection system. So that's a part of that OT cyber security. And also we have SOC, so the Security Operations Center, which can also work as a IT SOC and the OT SOC together. And then once there is an incident, then comes the response. How fast you are responding to that threat, or the approach, someone is approaching, then you detect, and then you approach or respond. That's the respond. And then it comes once there is a hack, or it may be some vulnerability became malicious activity happened, your plant down. Okay, you cannot access. So now what to do? how fast you can recover the system. That comes the recovery plan that we call as a disaster recovery. So these are the basic framework what we normally have for a niche framework, and we try to follow with the same thing with the other customers, manufacturers, whoever is thinking in that direction, digital transformations, because once we talk about digital transformation, it has to come. And we deploy, a defense in-depth layer concept. It's not like a single layer of protection, just like you put a firewall. Someone mentioned that, single layer of firewall, can it protect my system? No, because that can pose a vulnerability in your system. It has to be a multi-layer protections. It could be DMZ, it could be endpoint protection, it could be network assessment design. So it's like a multi-layered approach. So we prefer that, and that's how we create the zero trust and the IDMs and the network segmentations when we design the system for a OT system. And that's why, as mentioned, there are challenges with IT, OT environment. So we know OT. So in this case, for this cybersecurity journey, we partnered with Cisco, which is more than decades of strategic partnership between Rockwell and automation. So we created a framework or the converged network, which should be the ideal for a cyber-secured network. So this is a typical architecture normally, we suggest to the customers. You can see at the bottom, the zone 1, zone 2, zone 3, that's the layer 1. The bottom layer is the cell protection. So we create the cell, each machines will operate as a cell, so that you cannot access the one machine from other machines. And then we comes as a layer, as the access layer, then it comes a distribution layer, that's a layer 2. Then we come as a OT layer, okay, OT core switch. You can see all the machines will be connected there, okay. And this network is a well accepted, which is in line with the Purdue model as well. And then it comes the OT firewall, and then we create the IDMZ, and then we connect to the IT firewall, which is connected to the enterprise level, the cloud system. Now if you see the DMZ, now the traffic from IT does not flow direct through these DMZs to OT system. So no one can access from outside to internal. So that's how we create the typical architecture for a cyber security system. And it's a converged plant with Ethernet network, what we call is the holistic blueprint, what we prepare for a digital transformation journey for a customer. So, so that's about ourselves, that's what earlier was concept, generalized concept, vendor agnostic. Okay, so we work with customers where we work as a OT trusted solution partner, where we can, give you answer to these typical questions normally comes in your mind. Okay. So we can do that. We can work together, and we can give you build a smarter, safer, and secured, more connected operation for you. Thank you very much. If you have any questions, we can get connected later also in the lunchtime.
If you have any questions, please you can ask.
Or maybe lunchtime for the sake of time, that's also okay.
Thank you, Mr. Debashish Sarkar, for your nice speech. Before lunch, we have one more speech from Rockwell Automation also. I request Mr. Kallol Choudhury for his last speech before the lunch, and after that, we have a little quiz also. This is quiz number 3, and then we'll go for lunch. Over to Kallol Choudhury, please. Hello, hello.
So I'll not take much time now. Earlier we have seen how a connected enterprise, smart factory it can be, how can be a data-driven manufacturing can happen. So this is one small glimpse. So what I already told you, and many of our speakers told you, that Industry 4.0 is not a one piece of cake. It can have multiple small pieces. So I'll talk one particular piece of it. It is a AI solution. I'll talk 2-3 AI solution, very G's, because If I go depth, there are a lot of things to say. Means one whole seminar can happen on all these AI solutions. We have multiple kind of AI solutions like Guardian AI, Vision AI, Logix AI, Optim AI for energy optimization. Multiple AI ML solutions is now in the market, and these are live now. This is off-the-shelf solution you can use. Why I took two applications only? One is Guardian AI, then I will show you Vision AI, because I think that will be more relevant, but there is many other AI solution available, so that we can go in detail at a later stage. Okay. So first come on the challenge part. What is the challenge in the maintenance? There is some maintenance guy in the room, they can understand. One is reactive kind of maintenance and is proactive kind of. Reactive means anything fails, down, then you have seen dashboard, that VP operation saying this is down, why down, that plant manager is running there, or he is seeing from dashboard, oh, this motor failed, that failed, this failed. So those are reactive maintenance. If you can go something on proactive approach, because so many data are available, if you can analyze those data, if you can put some analytics on top of that, this analytics is not automatically coming from the system, ultimate human brain put in some coding, and off the shelf it should be available so that it can act and predict and detect before actual failure happening. Suppose the earthquake is coming, you have seen many hours before, 2-3 days before, some mouse or rats is coming out of the hole. Because that is some intelligence they have inbuilt. They have some sensor in their body. They can understand it is going to happen. So our job that is to build those sensors, build those intelligence in the machine. That is autonomous automation. Now industry needs that. That is actually industry 4.0. So I'll talk on that. So this particular, I just quickly jump on. So this Guardian is on something machine condition monitoring system based, and it had some direct business result. It can give customer like machine downtime reduction of 30 to 50%, increase machine life by 20 to 40%, or it can favor 80% of maintenance person as a part of a multi-facet maintenance strategy. So these are some business outcome you can get out of it. And what are the components? So you can use your existing devices as sensor. No data science required. When anything come on analytics or AI, ML, we always think we need some data scientists, we need some expertise. So technology would be so easy that everyone and anyone can use. To run a Facebook or WhatsApp, we need not to be a very much expert. So technology, if it has to be adopted in industry, it has to be easy. It has to be user friendly. It should be so easy that just click, drag, drop. Backend, maybe you have to do some coding, but for user, it should be easy, then only adaptability will come. And then it should have some intelligence to find the anomaly. A lot of people are already talking on that. And analyze those on the edge. This is another one important time. Someone having some comprehension, what is the data connectivity? If that connectivity goes off, what will happen? So this solution we are talking on the soft floor level. So it should not be dependent on connectivity or network available or not available, because real-time plant production will not depend on that. There are some catastrophic changes can happen there. But it was built such a way that it can analyze on the edge itself. So what are the components? So you have assets. So it can be pump, plant, blower. Why these assets? Because these are the big assets, costly assets. If fail, your total production can hamper and it can give a problem. So if it is a reactive kind of, once it fails, then your production halt. If you can predict those failures, you can take corrective action, it will not done. Along with those assets, you have to connect the VFDs, which will actually control those assets. And then we have this AI solution, and it will generate those anomalies and give you early alerts through email, through messages. So these are the basic components. So I'm running a little fast. I don't want to make you, that food is outside is ready actually. So this Guardian AI this has two parts. One is embedded expertise, another is user classification. This is important. Embedded expertise means from the motor current analysis from first principle, it is already built in. And on top of that, user who are using that, they can build all their own classification and can use that also. Okay. So if embedded, I say, embedded means off the shelf. When you buy this license, it is available, some fault for pump, like improper arm balancing, blade flow, all these faults for pump, fans, motor analytics, this is readily available, embedded. And you can build your learning or your knowledge, and you can build your alerts also on top of this same, using the same software. So it is a three-step. First is you have your VFDs which is connected with your assets. So drive will have a built-in sensor. You need not to put any extra sensor on the devices, pump, motor, fan. It will have its own current. From that it will analyze. So these are the device assets. It will be connected, and then Guardian AI will be deployed, and it will analyze, and it will give the alerts. So this whole thing is based on the actually motor current signature analysis, based on the first principle. So I'm not going very deep detail because there is some background technology already there. If you want to know that, it is available in Rockwell website also, or you can connect with us also. So quickly how it will be deployed, you have to put on each computer, anything can be, it can be done, and with the VFD and the assets, you have to connect all those things. And then from our production center, you have to download those licenses, load in your PC or laptop, and download that to edge devices. Why edge devices? Because if there is no connectivity, still it will keep on working. So these are some of the configuration scheme, how it has to be configured. And you have to put your asset detail, your bearing detail. If more data you feed the system, it will learn more quickly. It will learn more accurately. Okay. So it's all based on how much data you can feed on that software. And then the operation frequencies, you have to put that in the system. So more accurate you give it, it will give you the anomaly detection. These are the configuration summary screen. Then the system will first train itself, and you have to do the leveling, which are the frequency, fault frequency. If there is a vibration, which level you will call this a vibration. So all this has to be done. After this training, it is ready to start. So first it will do the initiate training, then stop, restart. It will do multiple start, stop, restart on those motors and fans and pumps. And then once it is done, it will build that mathematical model in the platform for that particular devices, for that particular assets, because all assets are mechanical items. They cannot be same. Okay, so that learning has to be done for individual assets. Then come the email configuration part. You can define who to get, what alert. You can put the email ID, you can put the frequencies, which fault to be sent to whom, that you can decide. So totally configurable. And these all things, not much training is required. Normally we have implemented many places where 2-3 days just training and people start using by their own. Okay. So these are the kind of email notification. So you may have in mind how powerful PC or server I have to put in the platform. This is the minimum that much is required. You need not to put any high-end server or anything. At least this much will work. Because why I am saying this? Because every analysis, everything will happen on these edge devices. So at least that much of capacity is enough to do that analysis. So this is the full picture. So all your assets connected with the VFDs, it can connect to your control system, and directly it will be connected to the edge devices, and it will do the analysis and it give the alert. Any anomaly detection, any alert, it will give it. So that is from my side, from Guardian AI. There is one small application on Vision AI. I quickly show you. Earlier was on asset health. This is on some production quality. So suppose there is a bottle can production happening. So this Vision AI, again another analytic solution which analyze the 360-degree view of the object, and it will have a GPU unit which is on cloud. Here we have to connect it with the cloud because that graphic processing unit need much computing capacity. Putting that kind of server in the plant will be a costly affair. So we offer a AWS or Azure cloud. But main device will be as a edge device installed in your plant. Only for processing part it will connect with the cloud, process and give any anomaly back to the edge devices, and plant level it will be available. Why you have to connect here with the cloud? Because of this graphic processing. Because it will consume very much high level of IT assets required. So everyone cannot put that in the plan, and not only put, you have to maintain that also. So we provide cloud service for that. And if as it is shared, economical part also very easy. So anyone can implement. Otherwise, economically it will be not that much attractive to the management to implement those solutions. Okay. So these are some of the use cases. I have few videos on that, but due to time. So this is one of the palette. There are some food grains are there. It is first it will learn, and then it will decide. These are the faceplate. It will decide if there is a foreign particle is there or any other object fallen in that part. It can detect that areas also, and it can give an alert. So this is learning part. First we have to capture, then leveling the problem areas. It will train, then it can be deployed. The earlier Guardian AI, same Vision AI also. First it has to learn, capture. It will build a mathematical model inside, and these all are self-learning. You need not to be a data scientist. A simple person who is operating on that, he can do that, and it will be ready to deploy. So these are some live use cases that we have already used on this solution. Like this one on manufacturing bottle, the label defect, somewhere is the capping is not proper, or material full is that perfect filling. We call it perfect filling. In CPG industry, one term goes excess giveaway. Sometimes you give the extra material. If you cumulatively calculate that, that is a loss. So perfect filling is the most important thing. So that can be achieved using this solution. So these are the various use cases. I am not going very detailed. So that is from my side. So I think you can continue.
Thank you, Mr. Chaudhary, for his speech. We will go to the next session. Our next session is the lunch session, which is very important. And before that, we have a Shuttu, please. Another quiz. I think you have enjoyed the first session before lunch session. We have thoroughly explained the objective of the seminar, objective of the events, one by Rockwell as well as Phoenix. They separately has explained all the necessary points for industry application of the IoT. And you will get your solution also. Those who are in the directly in the manufacturing industry, I'm sure that you will get your solutions in many of the aspects, and you can implement later on. I'm sure about it. So we have a last phase quiz. Shotto, please ask to Shotto come here. The question is, you see the Industry 4.0 basically is the ecosystem, and there are so many things actually clubbed together to constitute the concept of the IIT 4.0. Now, in the recent years also, you will find that Industry 5.0 has already come. So, you please mention one particular point which we cover under Industry 4.0. IT/OT conversion. Anybody else? At least one. Data analysis. Next. Real-time data analysis. Data analysis means real-time data analysis. Madam, you please. Anybody else? Question is this. You see, the Industry 4.0 basically is an ecosystem. So many factors are clubbed together to constitute Industry 4.0. Mention at least one important point which is under Industry 4.0. Okay. Cyber security is a point. More close to IT/OT already has spelled out. No, ChatGPT, no. You? Predictive maintenance. Data visualization. Sir, you please. You are looking very experienced from your end. Real-time data already has given. I am just giving you a clue. One is a cyber physical system is one particular point which is under Industry 4.0. And your answer is look here. Anybody else? AI analysis, machine learning AI is one of us. Yes, please come. Definitely many answers are there and many answer is true also at the same time, but I want the particular one which is AI ML. Yes, please come here. Your name please?
Sanjay Das.
Sanjay Das. You are from?
In the Indorama, India.
Indorama. Perhaps Ravi is being honored with a small gift. Okay, thank you. So thank you. আচ্ছা আমাদের লাঞ্চ সেশনটা কোথা দিয়ে যাবে কি করবে? So now it is the time for the lunch. কোথায় যাবে কোনখানে বলে দিন। অপ্রতিমকে ডাকুন একটু। Please wait just a minute. Explain from the Rockwell point of view product. So over to Shubhajit. Please, you can start.
আমার আওয়াজ শোনা যাচ্ছে? আমার মনে হয় আমার মাইক লাগবে না।
লাগবে না? এটা লাগবে?
ওকে, আমার ভয়েস ঠিক আছে? So, sorry everyone. Today is Saturday and after the lunch, it is a torture. And I am here to torture you because I am not going to give you a power nap or small nap, okay? So for that I just want to ask some questions from you before start my presentation. So this is, you are all from different industries. You are using HMI or visualization portfolio of different sections. So I have a few questions. Is your visualization platform give you the chance to connect as a software solution, like Git-based solution, like multiple person can develop a single software from different location? Is it there in your HMI portfolio? Is it there? Multiple persons from different location, different geographic location can develop a single software, SCADA? Plan teams from the in-house only, but not from the external. It's mean from the cloud they are not able to develop this solution. Is it possible in your present HMI solutions or the visualization? Possible. So which solutions that is? It's Git. You are using Git, and which software that is? The visualization software? Excuse me? Okay, that is CRM software. I say about the SCADA software. Supervisory control and data acquisition software, or you can say HMI software, human machine interface software. Is there any of the users who use this software and that have the capability for doing that? I think no. Second, I want to say that is your software can connect with your native language? It's mean either it is in Bengali or Hindi or Gujarati, Marathi, Tamil, Telugu, whatever language is there, your native language. Excuse me, sir? No. Third, is your SCADA software, you can deploy the software on the cloud from your local premises with the secure VPN connection. Is there any possibility for your software, for the HMI software, I just say HMI panel? Fourth, is your software support that IIoT-based SCADA or IIoT-based HMI from the HMI level to the cloud? It's mean it can share the real-time data to the cloud and you can access the data through a mobile application over the MQTT. Is it possible in your HMI software? Any response? Anyone say? No. Next, I want to say to you that today we are going different session and we know about the machine learning, we know about the integration between the machine learning with your software. But that machine learning language, can I directly import to my HMI software? Is it possible? No. Okay. So now I just showcase a next is solution. It is about a visualization software, but more than a visualization. So it is the single solution which can enable you to transform your industry to the next level. How? So before start, I want to introduce myself. So my name is Shubhajit Bodhak, and I am from Rockwell Automation. I started my career from Rockwell Automation in 2007. So in my career journey, I worked in Hindalco Industries Limited more than 6 years as an automation and reliability head. And also I worked for the, you can say global OEM like Epic. And I worked as a reliability head, I worked as a, you can say, a maintenance person, I worked as a software developer, and presently I worked in Rockwell Automation as a technology consultant. So my main role is to learn new things. Actually, I'm a very tech-savvy person, like you. So I learned lots of things, and after that, my duty is how to deliver those things to you, how to evolve you. So before start this, I want to share the visualization portfolio of Rockwell Automation. So we have a machine level HMI available like other vendors or other OEMs. So we have a machine level HMI like Panel View 5000, like Panel View Plus. We have a machine level HMI with the third-party connectivity software. So we support Capeware Enterprise is our own software. So we support that so we can collect the data over the OPC DA or direct access or OPC UA as a unified architecture access. And then we can develop a scalable HMI. So Plant PX is Plant, Process and Automation Excellence. So this is our distributed control system. So this is for the process industries. And nextly, I want to share you, or I want to introduce you with a new solution that is called FactoryTalk Optics. It is a cloud-centered development software. You can also develop this software in premises, okay? So you don't need any cloud connectivity, you can develop that. In that case, if you want to work collaboratively, in that time, you can use GitLab instead of GitHub. So GitHub is connected over the cloud. So now I have a GitLab in my premises, and we can use collaboratively developed a software. So when I developed a software collaboratively, it means it can create different version. Version means if I change something, I just change a value, I just change a position, it create a new version. And after all, when I go live, so ma'am also know about that, what is go live. So when I want to be go live, in that time what I did, I just merge those software as a project manager, and I create a new software. And this software can support your Windows-based platform, your Linux-based platform, even ARM-based solution like Raspberry Pi or others. So no OS limitation is there. You can implement this software or deploy this software anywhere. Not only that, we have a FactoryTalk remote access, a secure VPN connection, which can help you to deploy this application to the cloud. And it also support MQTT protocol embedded part of the optics software. So over the MQTT, you can also share the data from the field to the cloud. So you can develop the application which can collect the real-time data, and then it can use as a scalable HMI over the cloud. And over the, you can say web UI or web user interface, you can access the data anywhere from the world. Next, now I say that I can access the real-time data. What about the historical data? So this software has the embedded part of SQLite as well as InfluxDB for the time series data stamping. So now, before this session, at the morning, there is a question. If the communication between my cloud and my system is not established, or sometimes some problem or anomaly happen, what we'll do, what we can do? In that time, it can store the data in local, in the same time stamping, and whenever the communication is available, it will push the data and delete all the data which is previously stored over there. So we can provide the store and forward procedure, and we can ensure you that there is zero data loss solution we can provide. So now you have the historical data, you have the real-time data, so that you can also create some analysis solution or big data analysis or machine learning solution. So for machine learning solution, we need something. So we need some script-based solution like C# scripting or .NET-based some solutions where we can merge the, you can say from NuGet library, I collect a Python connector or some other connectors and I want to integrate that. That is also available here. So it is an open script-based solution, you can develop that. Now, if I say I want to collaboratively, it means I have a plant, I have an industry in Kolkata, in Singrauli, in Silvassa, like Hindalco developed something like called a common HMI solution, a common visualization software on the Hindalco main industries limited, and which can access from anywhere. So it helps us to compare from the one plant to other plant, and it can easily identify that what is the loophole, and we can easily access that. So it can give me the study of the other plants also. So same times, we developed a solution called FactoryTalk Hub on the cloud. It is a Rockwell solutions. You have the subscription-based options are there. You can buy it as a subscription, and then you can use the GitHub, and then you can use our FactoryTalk Vault, which can log the data, which can store the data, and you can develop this type of collaborative solution for your industry. So now, I just say that this software can connect anything. Can connect anything means not only Rockwell. So like Phonics have all the connector, we have also all the open connector available in this software. You can connect with Siemens PLC, you can connect with Modbus TCP, Modbus RTU, you can connect with Backup PLC, you can connect with Schneider PLC, you can connect with ABB PLC, you can connect with Rockwell PLC. Also, you can connect with old Rockwell PLC like SLC, the oldest PLCs over there. And after the connection, you need to do the contextualize. So my friend Kallol already informed you about the contextualization. So we can contextualize this software inside this software development. It means we have all the tool, we have the scripting possibilities over there, open scripting possibilities over there, so we can develop the contextualizing inside the software. Next, communicate. So it can communicate with MQTT, it can communicate with OPC UA. So it supports OPC UA server as well as OPC UA client. So you can easily create the communication between your low-level automation to high-level automation systems. And next, visualize. So you can develop the cloud-based visualization solution. You can develop something more. Now I come to the next part. There is a REST API mentioned there. So REST API also embedded features over there. So which support the REST API like SAP, you can say like Oracle, you can say like Kafka, like other softwares, other application software, you can directly connect it through the REST API. Even in the Telegram mobile application, so there is a chat application, so whenever any alarm happened, you can get a real-time notification. You don't need to worry about the Rockwell software in your mobile. Even an open chat application can access that there is a problem in the plant, so I can easily collect the data from there. Next, OPC UA, I already informed. Embedded database, SQLite. So SQLite also support the Grafana. InfluxDB also support the Grafana. So if you want to create some Grafana dashboard for your plant, you can easily do that using the database. Now, the thing is, previously we worked with the different types of data log solutions. I think, okay, different types of data log solutions. So data log means I log the data on an external server. So when I log the data to external server, in that time, if I want to create a report, I want to write a VBA script to pull the data from the database, then I create the report. But here, as it is a part as an embedded SQL, so we can run directly SQL query from the software. So we can create the report as a no-code solution, just drag and drop, and you can create the report. Next, cloud-based development and open C# script is available here for your integration with other software and other platform. So now, if I say about the FactoryTalk Optics, how it enables you to evolve your industry, so multi-user collaboration with the version control solutions, responsive graphics. So responsive graphics means presently you developed a SCADA or HMI, and now you have a problem on a machine and you want to just use like your 2 fingers and want to just zoom it to check what's happened. You can easily do that. So responsive graphics give you these features. So not only that, you can create day mode, night mode in the runtime. So day mode, when in the morning you are working, and suddenly when night time you are working, you want to put in the night mode, so its background become a black, so it is easy to identify the problems. Library management, so normally we know about the HMI or SCADA software, there is a graphics library, but here we also have the features library, as all the features are embedded. Also we have some development library and some software library inbuilt over there. Pre-built content already available, so you can seamlessly connect with Rockwell high level of automation solution like the Guardian AI, Logix AI, Fix, like CMMS solutions, so other softwares. Also we have an open architecture which support the fully C# scripting. So on the .NET platform you can develop those scripting and you can interact with your own Power BI application or other applications. IIoT and smart solutions can available. So Rockwell controller also comes as a smart object solution. So you don't have to contextualize the data on a different platform. In the logic itself, you can contextualize data and you can directly pull the data as an object or information model. So you can directly get the OE, get the MTTR or MTBA from the machine through the controller to the system. So you don't need to develop anything. Third-party support, so it supports all the controllers, all the different platforms. Remote management solution also available here. So all the factory-talk optics solution as a SCADA, as a HMI, as a ARM-based solution, it's come with factory-talk remote access enabled solution. So factory-talk remote access is our VPN solution which can give you the chance to connect with the external system with all types of security. So there are two layers of firewall is there. One is the device level and second is the cloud level. And next, it's a modular and scalable. So if I have only one Rockwell controller or if I have only a Siemens controller, why I pay everything for the others? Not only that, those scalable solutions are the open scalable solution. It means today if you have a Siemens controller in your plant and tomorrow you plan to change that software with the Rockwell or change the platform with a Rockwell, you don't need to buy again this software. Instead of the Siemens controller, you use the same token or same activation for the Rockwell controller. So now about the development software. For your information, the full feature software is a free software for development. You can develop the software by yourself, especially for the students. You can interact with that. You can download this software, you create a Rockwell account, and in free you can download this software and you create your own development using this software. Only when you need to do the collaboration part, so in that time you have got those features like you have a design level editor available on the cloud. You can use that. You can able to use the cloud space to store your data. You can create the version control. Otherwise, all the features like MQTT, OPC UA, third-party controller communication, reporting solution, REST API, you can develop by yourself in your free software. So I just give you just heads of those features which is available in the factory-talk optics. First is you don't have the software in your laptop. So how you can connect the software, how you can develop the software. Don't worry, it is available on the cloud. So if you have the subscription model, you can develop on the cloud. You can use different version of the factory-talk optics software from there to develop the solutions. If you don't, yeah. So online like a Gmail platform. So you have open the Gmail mail bodies come. So you don't need to install the software. So same like this software, it's give you the open platform on the cloud. So you just need the subscription model and you can access the software. From there you can pull the software, create new version, and then you can develop the software. Create your own application and deploy anywhere. So now in present condition, when we are saying even in the Rockwell automation, we have a HMI solution like Panel View Plus. So for the Panel View Plus, I need a software called factory-talk View ME. If I have a SCADA software, factory-talk View SCADA, so I need factory-talk View AC application. But here, you have only one application to create. And that application is a responsive application. It can resize, it can replace the even application. So you don't need to create multiple times, multiple application for multiple devices. You can develop the application once, and then you can deploy the application either on HMI, either on the SCADA platform, either on the cloud, either on the web UI, either on the Raspberry Pi, like the, you can say, ARM-based solutions. Pay what you use. So you have to pay only what features you want to take. And those features also independent. You can use those features for the other features if that is not required. Next generation dashboarding. Now we know that when we developed a dashboarding solution on the SQL Server reporting solution or Grafana, we need to download some, you can say, charts from the net, like Apache chart or Google chart. Here you can also download those charts and you can apply here directly. So you can create your own dashboard without depending on the SQL Server reporting solution or other open solutions. You can develop everything in your HMI itself or the SCADA itself. Next generation report, as it is support as a SQLite, as embedded features, you can run the SQL query and you can create report as a drag and drop solution. You don't need to do anything. Even in the report, you can develop a chat application communication. So sometimes what happens that I have a problem in my plant and maintenance team inform over the WhatsApp to a team that there is a problem, you just come and access the data, solve the issue. But when they do the root cause analysis things or the corrective action and preventive action things, they only write what is the solution, not write that what I try and it is not fulfilled. But here, you can use the optics chat, and then whenever you communicate during the failure and when you take the report, you have got all the information, what is the communication between two persons, also the trends, also the pie chart, or you can say histogram chart, also the grid data, also some data like image and other things. Next, so I give you a solution which can connect with multiple PLC, multiple systems. So if there is a limitation of the tag and the screens, then it is not fruitful. That's why this software comes with unlimited tag and unlimited screens. So you don't need to worry about the limitation of the tags on the screens. Only you just check that what system you want to develop. If you want to develop the whole level of SCADA or distributed level of SCADA, in that case, you don't need to select that HMI panel or ARM-based panel. In that case, you have to select a Windows-based systems. Next, enable third-party controller, that is I have already described. Now the OPC UA. So OPC UA is the DNA of the FactoryTalk Optics. You can create OPC UA server. Also you can create OPC UA client. And all level of security is there. So all types of certificates also you can create over there. So you can connect with the high level of OPC UA server like your ERP solutions or the other solutions. MQTT makes this system as the IIoT enabled HMI. Next, Open C# scriptings help you to create the API between different softwares. Next, multi-language and multi-IS. Not only multi-language, multiple industrial standard, or you can say international standard you can create over there. So when an operator log in, if he is very much familiar with the Bengali language, whenever he log in, he check everything in a Bengali language. If some operator in Hindi language, so you know about that. Some of the project persons or the operator, they are as a project affected pupil and they are not that much familiar with the English language. So it will help us. Now, it is also come with embedded video, PDF and web viewer. Why I say embedded? Because all the softwares can deliver those things, but what is the difference between optics and the other softwares? All the softwares that's embedded with these things, but there is called ActiveX control. ActiveX control means if I want to see a PDF viewer, in the back end I run an Adobe Reader. Then it will pull the application and then it will deliver the PDF file. But here it is not. So that is why even when alarm comes, automatically a view options comes. There you click, you can see a SOP or SMP. So it will help you or enable your operator to identify what is the problem and what is the procedure to solve the problem. Now it's all about the version control, what you asked, sir. So we support the FactoryTalk Vault, which is the subscription base, and it's also available in the subscription model. But you also have the GitHub, GitLab, Bitbucket, and if you have Azure DevOps in your own cloud, you can also develop the version control over there. So how the version control works? So in a different location, different person works in the same software. And it will create a different version. It will store in as a version options, and you can select the version in the central repository, and then you can go live. So for the Windows-based system, it can develop a .exe application, so you don't need to install anything in your Windows PC. For the Linux-based system, it will create .sh-based application and ARM-based .z-based application. So after merge everything, you can deploy the application any devices or any systems. So you can do the containerized UI layout. Containerized UI layout means ARM-based UI layout. So you have developed an application and then you create a web UI, and from the web UI you can access the data. Now that web UI may be run in the Google Chrome, maybe it is run in the Internet Explorer, maybe the size is the tab, or maybe the size is your normal mobile phone. So based on that, you can different layout can create easily. Flexible navigation styles. So for the navigation, we don't need to create anything by retain or by drop down something. It is the embedded navigation. You just drag the navigation page, and after that you drag all the screens, automatically create this navigation screens. Modern controls available there. So as it is support the C# scripting, you can create different types of, you can say buttons or different types of things which you previously developed for the any CRM application or SSR-based application, you can do that. Video player is the embedded part of that. So as I say that when the problem happens, you just check and you can access the things over the PDF, that what is the SMP or the SOP. You can create also video SOP over there. PDF viewer is there. Web browser is there, so web browser helps you to pull those e-chart or other things. Alarm management is there, so when the alarm happen, it can get the notification over the mail. So email features, SMTP server also supported this one. And also you can get this notification on the Telegram applications. Email notification is there. Remote access support, FactoryTalk remote access is the embedded part. And user security. So as it is support the cloud-based development or cloud-based deployment, so it also support zero auth security. So when you work with the Microsoft Azure cloud or some cloud, so in that time, this authentication is required. So where you deploy which type of application? For the machine operators, you deploy this application for the HMI. Next, for the SCADA application or line operators, you can deploy the same application in your SCADA. You can also the ARM-based solution which can directly connect in the chassis or a DIN-rail mount. So from there you can access the data or KPI over your mobile phone. Also, if you have a cloud development software or cloud development solutions, you deploy the application on the cloud, and then from anywhere in the world you can access the applications, like the PyVision. So this is some visualization operation trends, okay? So against the traditional HMI to today's visualization system. So network hardware, we can reduce more than 84% connected devices are, which of the following smart manufacturing hardware and smart devices presently in the company adopted for the next adoption. So you can see that how much PLCs, how much PLCs in the control system or platform we can access the data, we can develop this type of solution. So this much percentage we can easily do. Okay, okay. Thank you. So now I want to say how the visualization system works as a edge solution. So now I want to share that you don't need any other softwares or other connector or other device to create your IIoT tunnel or your visualization software. So we already have the physical devices over here, okay? So those may be smart devices. Over the IIoT, it can share the data. From the, you can say drives, it can directly pull the data from the drives if it is a Rockwell drive. If this is the mobile production data, you can collect the data through the REST API. And if it's the controller data, you can directly control it using the controller connection or third-party connector to collect the data. Then you develop or contextualize everything in your application. Then through the high-level connector or connection, you can share the data to the cloud or other application. Like this Plex application is our MES application of the Rockwell, which is sitting on the cloud. FactoryTalk Data Mosaic, it is our DevOps application, which is sitting on the cloud. Fix, it is a centralized maintenance management solution. This also sitting on the cloud, and all the library for this software is available inside that. Okay? Now, so if in your plant, you don't plan to just change your level of automation, layer of network, you can also create the machine-to-machine communication over the OPC EUA. Just put a HMI or a DIN-rail-based mount, DIN-rail-based device, and then from that HMI, you can also collect the data over the MQTT to the cloud. So you just put a firewall, and after that, over the MQTT, you want to share some data, you can share the data, and from anywhere in the world, you can access those data. So only changing two HMI or only changing two ARM-based solution or just a two DIN-rail-based mount you can put there, and after that, your plant now smart one. So this type of dashboard you can easily create, and this type of trends you can also create. So all the solution is the drag and drop solutions. You don't need to develop anything or coding anything to create those solutions. Not only that, for the report, when you create the report, the header, footer, and other parts already come. So you can create the report by using the drag and drop solution. You don't need to do any scripting or VBA script for that. Now where we can deploy the application. So what type of devices we have where we can deploy this application. So we have the edge-based device which can easily directly install on the ControlLogix controller. Also we have a DIN-rail-based mount device, ARM-based device, Also, we have a different size of HMI panel is available for that. And also, we have a SCADA. So, anywhere without respective of any OS, I can deploy this solution to any devices. So, we have this types of features available over there. So, we have the SM IPCs, SM box PCs. So, SM is the Italian company. We acquired this company 3 years back. So, this company provided all the hardwares and all the features for the factory talk optics. Then optics panel also developed by the SM. So this device we can deploy the application. Embedded edge compute module, this is the control logics based compute module. So this module developed by Rockwell Automation itself. And this is the new solution called optics based. It's just like a small, you can say switch, small communication switch. And it's also act as this device. And for these two devices, we also have a containerized applications available there. So you can create different container inside that, and then like an InfluxDB container or Grafana container, you can create inside that, and you can develop the applications. So this is something that how it looks like for the responsive design. So when you use the responsive design, it automatically select the device size and device resolution, and it can create those data. So it is something like that. Also, we have the device object library. So whatever Rockwell devices we have in our portfolio, those libraries are already available. So you can use those library. You don't need to develop anything in that case. I just say about the style sheets. So style sheets give you change the background color, change the device color. Even you can create a e-tagging. So what is e-tagging? So normally in the plant, when we have a multiple conveyors and multiple conveyors supplied by different vendors. So it can happen that one conveyor is in maintenance mode, and there is a proper tagging also there, but the second conveyor is not in maintenance mode. So sometimes someone just go for the maintenance activity and sitting on the second conveyor, which is not in maintenance mode. And from the plant scenario, from the operator control room, he can see that before start any machines, we normally test the machine. It's been test out. So we run the machine. He run the machine and some accident can happen. So that is why when we are saying Indian Manufacturing Excellence Award or something, they are saying about e-tagging. It means the tagging also available on the SCADA screen that this machine in the maintenance. So you can also create this type of style sheets. So when the maintenance mode is running, you just enable this part so it can change the color of that particular machine. So from the operator console, the operator or the process person easily understand that there is some issues are there, so he not run that particular systems. Also, as I say, it is an open API is available. So from there, you can easily run, create a .NET applications for runtime net logic or operation net logic, and you can create like a software platform. You can create multiple devices, or in the runtime, you can interact with multiple systems or multiple solutions. So this type of scripts, where we are using, presently we know that if I have some data in my database, and I want to pull those data for my recipe from the database, this is not developed in the HMI. So for that, what I do, I just pull the data from the database, then I send the data to the controller. But it is not possible for the present scenario or present SCADA. But here we can do that using those script features. So it is all about the language and other things, so language and standards. Also, we have extensible library options are there. So that is mentioned here. So now I want to say about the data solution. So we just say that we have a multiple things, but how it can evolve your industries, I want to show you. So the same thing. So you can see we can create this type of dashboard to connect with the system and collect the data, see the real-time data for the individual plant. Also, we have options to create a smart machine using this solution. How? So we have intelligent devices which is connected over the IIoT. Then we have a control layer. So in the control layer, we have the smart objects which can create the information model inside the controller without using any other software. Then we have a visualization platform option where we just put the factory talk optics over there, and from there we can directly send the data to the cloud. So we can eliminate this edge part or edge end premises solution. Normally when we just destroy one part, it means I just cut one part, automatically the speed become high. So we can easily do that. And how it is looks like, so for why it is required actually. So when we do the basic quality check, we do the CLITA, cleaning, lubrication, inspection, tearing activities and other things. So there normally we visually inspect those things. When we do enhance our diagnostic, we normally put some sensors over there. But when we are sharing that, when we are required the advanced analytics or some predictive solution, we need to send those data on the cloud because the large space is required, because the communication between different APIs are required. So we can easily do that using the smart machine solution. So your machines become traditional to smart when we deploy this solution to your systems. So how it will work? We have a controller, we have a factory talk optics. Over the factory talk optics through MQTT, OPC UA or REST API, we can directly connect to the cloud. And also, after collect the data with the secure VPN, I can show the data on my development platform. So we can easily debugging those solutions. So this is something that where we don't develop anything inside the factory talk optics. We use the smart object, and we have all the object libraries available here for the data ready solution, and we use this application to develop this application, develop this types of dashboard. It means all the OE, performance, availability, quality, you don't need to do anything in your software. It can easily develop and deliver to you. Also, there are different types of faceplates are available here, which can you directly use and connect to your system, and you can get the data. So now, if I want to say about the architecture of a factory talk optics, you can see factory talk optics sitting middle. It can connect with Rockwell controller, third-party controller, over the OPC UA different devices, over the MQTT different devices. After pull the data on the optics, you can connect with SQLite, which is the embedded part of the optics. So this is the this is the SQLite, which is the embedded part of the optics. Then with the SQL server, we can create the store forward procedure. When the communication is not available, it will store the data on the factory talk optics. After that, it will send the data. Also, file transfer protocol is available there. Factory talk remote access, the VPN connectivity is available there. Over the MQTT, I can share the data on the Mosquito. Not only that, if you have the Azure solution, we have the IoT Hub connector, which is the part of the Azure to connect with the IoT data. And you can develop this solution. Then you can create reports seamlessly from the device. You have a web client option from where you can access the data to any devices. You have a OPC UA client option, so you can create an OPC UA server in your factory talk optics, then share the data to the client. And there are multiple possibilities available here when you connect to the subscription model or cloud-based model. So I want to show some features of the factory talk optics. So this is the data ready solution which I developed. Yeah, just a minute. Yeah, please.
For this FT optics, a historian should be there. Is it all dependent on
The embedded historian is there. Embedded InfluxDB is to come with the factory talk optics. 100 मिलीसेकंड, क्योंकि वो उसके अंदर ही है. जब मैं डेटा लॉक करता हूँ ना बाहर, जब मैं भेजता हूँ कहीं पे, तो उधर बफर रहता है, इसमें बफरलेस रहता है. नहीं, मतलब इसमें हिस्टोरियन का जरूरत नहीं पड़ता है. हाँ, हाँ, राइट. नहीं, फैक्टरी टॉक व्यू एसी जो है, दैट इज वी आर usually use for the our distributed control system or plan PX. Because plan PX में क्या चाहिए होता है, लाइब्रेरी चाहिए होता है, ऑब्जेक्ट लाइब्रेरी चाहिए होता है, डिवाइस लाइब्रेरी चाहिए होता है, और वो पर्टिकुलरली रॉकवेल ऑटोमेशन के लिए बना हुआ है. So if you are using the Rockwell automation DCS, in that time you must select the factory talk optics. But with the factory talk optics, we have factory talk view, we have a multiple use case. We also provide the factory talk optics as a reporting solution and dashboarding solution and a historian solution. हाँ, इंटीग्रेट कर सकते हैं. So what we did, आपका एसी लगा हुआ है, एसी में रॉकवेल का डिवाइस लगा हुआ है, आप लोग ईबा भी यूज करते हो. सो ईबा क्या करता है, डायरेक्ट कनेक्ट करके डेटा उठाता है, ये डायरेक्ट कनेक्ट करके डेटा उठाता है. इसमें अच्छा क्या है, ईबा जो रिपोर्ट बनाता है एक लिमिटेड रिपोर्ट बना सकता है, वो एपीआई नहीं बना सकता, बट ये एपीआई रिपोर्ट बना के इंटीग्रेट हो सकता है फैक्टरी टॉक व्यू एसी के साथ. सो यू कैन गेट द एंटायर प्लेटफॉर्म सॉल्यूशंस, राइट राइट राइट। सो मैं जो एम्बेडेड डेटाबेस बोल रहा हूँ, अगर मेरा उसके अंदर ही वो सेव रहेगा, तो स्क्वेयर लाइट जो होता है, डॉट स्क्वेयर लाइट बोल के उसके अंदर एक फाइल बन के सेव होगा। अगर इन्फ्लक्स डीबी है तो स्क्वेयर लाइट टेबल के अंदर ही रखेगा, और जब वो कम्युनिकेट होगा, फिर से कम्युनिकेशन जैसे स्टैब्लिश्ड होगा, सेम टाइम स्टैंपिंग डेटा वो पुश कर देगा दूसरे सिस्टम में। राइट राइट राइट। अगर इस हिसाब से बंद होता है तो मैं ये वाला सोल्यूशन जो दिखा रहा हूँ, स्मार्ट ऑब्जेक्ट सोल्यूशन, दैट स्मार्ट ऑब्जेक्ट सोल्यूशन स्टोर द डेटा इन द कंट्रोलर, एंड दैट स्मार्ट ऑब्जेक्ट डायरेक्टली रीड फ्रॉम द ऑप्टिक्स। लॉजिक्स के ही रहेगा, लेकिन उसका एक लिमिटेशन रहता है, मतलब उसका भी 20 MB कंट्रोलर होता है, 40 MB कंट्रोलर होता है। ऐसा नहीं कि मैं 2 दिन बंद करके रखा, इट्स नॉट पॉसिबल। वी कैन सेट दोज स्मार्ट ऑब्जेक्ट साइज ऑन द कंट्रोलर, सो उस टाइम पे वो स्टोर रहेगा और इस टाइप से विजिबल होगा। राइट। सो रियल टाइम में ये डेटा दिखा रहा है अभी, जो डायरेक्ट इधर से उठा रहा है। इधर रियल टाइम डेटा छोड़ के भी देखिए, डाउन टाइम 10 मिनट्स दिखा रहा है, तो 10 मिनट्स का डेटा मेरा लॉजिक्स के अंदर स्टोर है। और उसके बाद मैं चाहता हूँ कि इधर से परफॉर्मेंस, अवेलेबिलिटी, क्वालिटी, ओवरऑल ओई, ड्रॉप डाउन टाइम क्या था, एक मशीन को मैं पर्टिकुलरली देखना चाहता हूँ, उसका यूजेस कितना है, उसका किलोवाट कितना एज्यूम किया, कंज्यूम किया है, बियरिंग टेम्परेचर क्या था। थर्ड थिंग इज, ये एक मॉडबस के साथ कम्युनिकेशन किया हूँ मैं, तो इसमें मैंने 2 ऑप्टिक्स एप्लीकेशन यूज़ किया। मॉडबस के थ्रू मेरा ये एप्लीकेशन कनेक्ट है, और दूसरा एप्लीकेशन इधर से OPCUA में वो डेटा उठा रहा है। तो मैं इधर से जब वैल्यू चेंज कर रहा हूँ, इधर मोटर रनिंग दिखा रहा है, 40 हर्ट्ज दिखा रहा है, चेंज किया मैंने वैल्यू। अभी मैं दूसरे एप्लीकेशन में चला गया, इधर देखिए रियल टाइम में इधर डेटा OPCUA के थ्रू आ रहा है, और इधर देखिए उसका डेटा डायरेक्ट आ रहा है। तो मैं अगर उधर मॉडबस में भी चेंज करूँगा, इधर भी उसका रिफ्लेक्शन आएगा कि इधर वैल्यू चेंज होगा, 10 MB, 20 MB। सो ये फुल्ली सपोर्ट करता है OPCUA को। और नेक्स्ट मैं एक दिखाना चाहता हूँ कि डेटा सोल्यूशन। सो इन्फ्लक्स डीबी ये सपोर्ट करता है, इन्फ्लक्स डीबी ग्राफाना के साथ इंटीग्रेट होता है सिमलेसली। सो मैंने ग्राफाना में कुछ डैशबोर्ड बनाया है, एप्लीकेशन डैशबोर्ड। सो यू कैन डायरेक्टली क्रिएट दोज डैशबोर्ड्स विदाउट डिपेंडेंट ऑन द एक्सटर्नल हिस्टोरियन सर्वर और एक्सटर्नल सिस्टम्स। यू कैन डेवलप द इन्फ्लक्स डीबी सर्वर इन फैक्ट्री टॉक ऑप्टिक्स, एंड देन यू कैन इंटीग्रेट। और अभी मैं एक रिपोर्ट का दिखा रहा हूँ, रिपोर्टिंग सोल्यूशन। तो ये ग्रिड बेस्ड रिपोर्ट बनाया, ये ग्रिड बेस्ड रिपोर्ट बनाया। ग्रिड बेस्ड रिपोर्ट बनाने के साथ साथ मैं अगर देखूंगा तो इधर पाई चार्ट में दिखाया कि लास्ट जब वो डेटा उठाया तो उस टाइम पे क्या वैल्यू था, वो छोड़ के भी ट्रेंड्स का डेटा दिखेगा। ठीक है, अभी मैं एक काम करता हूँ, इसमें एक ऑप्शन रहता है कि आप स्क्रीनशॉट भी ले सकते हो, डायरेक्ट जो स्क्रीन चल रहा है उसके स्क्रीनशॉट ले सकते हो। इधर मैंने एक चैट एप्लीकेशन बनाया है, तो इधर से वो पूछ रहा है कि मैंने हाई किया तो उसका इन्फॉर्मेशन आ गया, मैं उसके साथ कम्युनिकेट कर रहा हूँ कि मेरे सिस्टम में कुछ प्रॉब्लम है सर, तो मैं कैसे सॉल्व करूँ। तो उन्होंने कुछ बताया कि मैंने हेलो सर किया, तो इधर मैंने फिर से कम्युनिकेशन में कुछ लिखा कि मुझे कैसे सॉल्व करना है। जस्ट ए मिनट। इसमें रिपोर्ट वाला वो दिखाया नहीं है। एनीवे, तो वो जो कम्युनिकेशन हुआ, वो कम्युनिकेशन भी उस रिपोर्ट के अंदर ही आ जाएगा। जब चैट में हम करेंगे ना, तो रिपोर्ट के अंदर आ जाएगा। हाँ, हाँ, एसएम लगा हुआ है तो देखना पड़ेगा। वो विंडोज पे से आईपीसी है या पैनल आईपीसी है ना, डाल सकते हैं। विंडोज 10 है या विंडोज 11 है, हाँ डाल सकते हैं। उसको हटा के ऑप्टिक्स डाल सकते हैं आप, यूनी को हटा के। नहीं 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 नहीं, वो एम्बेडेड एज मॉड्यूल है, उसके अंदर ऑप्टिक्स रहता है और कंटेनर सर्विस रहता है। इसमें मैंने एक बॉट एप्लीकेशन बनाया है, जो मेरा प्रॉब्लम्स आता है, प्रॉब्लम्स के अगेंस्ट जो क्वेश्चन आता है, तो क्वेश्चन में मैं इधर से ही देख सकता हूँ क्वेश्चन का आंसर कैसे करना है, मतलब क्या क्या सॉल्व करना है वो मैं देख सकता हूँ। वो छोड़ के मैं इधर एक रिपोर्टिंग सोल्यूशन बनाया हूँ। जस्ट इसमें आप दे सकते हो कि आपका इस टाइप का प्रॉब्लम आएगा तो कैसे कर सकते हो, तो इस टाइप का विजिबिलिटी आप दे सकते हो सिस्टम में। और आप डायरेक्ट इधर से हेल्प फाइल में भी जा सकते हो डायरेक्ट. आपको कुछ डेवलपमेंट में प्रॉब्लम हो रहा है तो क्या करना है वो क्वेश्चन आंसर में भी जा सकते हो. मैं थोड़ा फास्ट करता हूँ इसको. अभी मैं दिखा रहा हूँ कि ये पावर डिवाइस लाइब्रेरी है. तो ऑटोमेटिक जो ड्राइव्स का लाइब्रेरी होता है वो इसके अंदर विदाउट एनी कंट्रोलर, अगर आप ड्राइव्स का डेटा चाहते हो तो वो भी इसके अंदर डेवलप कर सकते हो. वो ड्राइव से डायरेक्ट कम्युनिकेट करके डेटा उठा सकता है आरए ईथरनेट आईपी में. तो उसका लाइब्रेरी भी इसके अंदर डेवलप्ड है. ड्राइव्स कनेक्टेड नहीं है. आप सोचिए आपने एक पावरफ्लेक्स 755 खरीदे. अभी चाहते हैं आप, आपके एचओ से बताया भाई हम और पैसा नहीं देंगे तुमको स्काडा लगाने के लिए. आप बोले सर दूसरे स्काडा में नहीं लग सकता. तो आप एक ऑप्टिक्स पैनल उधर लगा के, जो छोटा होता है 4 to 7 इंच का होता है, वो लगा के वो ड्राइव्स को डायरेक्ट कनेक्ट कर सकते हो. कुछ नहीं डायरेक्ट ड्राइव से. हाँ मतलब पैरामीटर्स, ऑल पैरामीटर्स. तो आप पैरामीटर चेंज करना है तो आप जैसे हिम यूज़ करते हो ना, हिम के जगह इसको एज ए आरटीयू हिसाब से यूज़ कर सकते हो. ठीक है. ये समथिंग हमारा CMMS बेस्ड सोल्यूशन है, कंप्यूटर बेस्ड मेंटेनेंस मैनेजमेंट सोल्यूशन. तो मेरा अगर रन टाइम ज़्यादा हो गया है मोटर का तो ऑटोमेटिक एक वर्क ऑर्डर क्रिएट कर देगा मेरा क्लाउड में. तो उसका पूरा लाइब्रेरी इसके अंदर बना हुआ है. तो मैं इसको रिफ्रेश करूंगा अभी और एक बार. तो रिफ्रेश करूंगा तो मुझे जस्ट ए मिनट, देखिए मेरा एक वर्क ऑर्डर क्रिएट हो गया. तो ये क्या करता है, ऑटोमेटिक वर्क ऑर्डर क्रिएट करता है. क्रिएट करने के बाद उस वर्क ऑर्डर के रिस्पेक्ट में जो फाइल चाहिए, जो SMP चाहिए, SOP चाहिए, स्पेयर पार्ट्स क्या क्या है, SAP के साथ इंटीग्रेट करके डेटा उठाना, सब कुछ कर सकते हैं. और आप उसके बाद उसको क्लाउड में जाके आप कुछ भी क्लोज कर सकते हो. मतलब वर्क ऑर्डर क्लोज करना है, वर्क ऑर्डर चालू करना है, वो कर सकते हो. This is something that I want to show you about the multi-language features. So this one is the one SCADA. So I just log out from here and I select one person who is not from India, he's from Italy. So all the language change to Italian language, okay? But it is not valuable for us. So I do one thing, I just log out and select my name, Subhojit Bodhak. Now you can see everything is in Hindi. Even on the alarms and everything is in Hindi. So you can interact with your native language. Now I do one thing. I just select a person from Bangladesh who just log out here. Just a minute. So everything is in Hindi, it is showing. Now I just select a person who is from Bangladesh. I just log out and select his name, Muhammad Farhan. And when he logged in, everything is in Bengali. So I think the resolution is not good. So that is why it is quite difficult to understand, but it's all in Bengali. So this multi-language features is available on the optics. So if you change the user, you can set what type of user they are, what type of IS they want to use, what type of language they want to use. You can easily do that. हाँ बताइए सर.
जो क्लाउड पे डेटा जा रहा है, अगर मैं चाहता हूँ पैरेलल कोई STD के अंदर भी पैरेलल वो डेटा रहे.
हाँ राइट. हाँ कर सकते हैं आप, 2 डेटाबेस कर सकते हैं. इधर मैं जस्ट शो किया हूँ. जस्ट ए मिनट, मैं पहले से दिखाऊंगा तो अच्छा रहेगा. इधर में टीम्स के साथ आई जस्ट इंटीग्रेट विद माइक्रोसॉफ्ट टीम्स. सो व्हेन अ प्रॉब्लम हैपन, वी हैव द factory talk remote access in my plant. So I have an original equipment manufacturer who can help me as a you can say digital AMC or from the remote AMC. So I just create a work order from my HMI that I have a problem, please take the system online and solve my issue. So I just put my problems over there and after that I submit the issue on my systems, okay? So what happened, let's see. Just submit the problem and when he open his Microsoft Teams, he can see there is a new notification comes to his system. He just go there from the Microsoft Teams, there is a problem, he just open what is the problem and then he just click on the remote access And after click on the remote access, he directly go to the remote-based platform or the VPN connections. And from there, he can easily connect. He must select the organization where he needs to help. So for that, two multi-level authenticator is there. So multi-level authenticator, he put his key over there. And after that, he can connect with the systems. Okay, I just little bit fast. So he must select the organization. So I just select that this is in Rockwell Automation Kolkata. So he must select Rockwell Automation Kolkata. And then after select, he can directly jump to that particular organization. And from there, over the VPN of two level of firewall, he can connect with my device. So from here, he can see my PC. So he selects Subhojit PC and the interactive access he can click. Not only that, this VPN log all the things as auditory compliance. Who connect, when connect, why connect, what type of changes you have done, everything is locked over there. So for the audit trail, you can also use that. So, and from here, he can also change the status as a close. So that work order is closed, you have all the audit data, when it is connected and what type of support he provided. So you can easily track the OEM activities and you can inform it. You give me support for 3 hours, 4 hours, you can charge for that only. This is about a chat notification. So I just do one thing, I just create an alarm. When I create an alarm, a notification comes with the emoji that there is a problem in that particular area. And also when I clear the problem, it will give me the notification the problem is clear with the emoji. You can click report, so it can also be scheduled, so automatically report will create it. And after that you can send directly to your mail ID. So the report automatically attached over there and it will go to your mail ID. So you can create a, you can schedule a things that every 7 AM automatically report created and automatically delivered to different mail IDs. You can also create that. Also if there is an alarm, after create an alarm, automatically a notification comes to his mail ID that there is an oil tank level high or with the report and everything. So this is about a Siri integration, so a voice command integration. So this is my voice, I think this voice is very good.
Siri, you can give a voice commands and then, so they can also, they can on the projector, they can also down and just, let's start.
So I use Khulja Sim Sim.
Hey Siri.
Then the curtain will open.
Please create a note.
What do you want it to say?
Khulja Sim Sim.
Done.
So after that it will open.
The curtain is open now. Hey Siri. So you see that motor is running. Please create a note. Hey Siri. Please create a note.
What do you want it to say?
Stop the motor.
So I give a command, stop the motor.
So now the motor stopped.
The motor becomes stop.
Now I give a command to again start the motor. Hey Siri. Please create a note.
What do you want it to say?
Start the motor.
Done.
So you can see the motor start running.
So I can give a command to make level high, make level low. So you can do this
Hey
type of
Siri.
automation for your, you can
Please
say
create
meeting
a
room.
note.
Please on the your projector or put off the
Fill the
light
tank
and it can
loaded.
easily work. Okay, so it is little big, so I just jump to other application which I developed with the Alexa.
Good morning everyone. So as I show you that the applications using the
So
Siri,
here
how
I
we can
use
integrate the Siri application
Node-RED.
inside the Optics.
So
that
Node-RED
if you hear
helped
any
me
voice coming
to
through the Siri, you
create
can
the API
take
between the
access.
Alexa app
Now I'm
and
going to
this
demonstrate
one.
the same thing using Alexa. Okay. So here I have the Alexa app
Okay, so when I say something, just with her name, he opened the application. So if I give any comment here, it will work on the application. So how I define that? So in the screen you can see we have the Ddm-Iiot. So Ddm-Iiot help us to create a pipeline between the voice monkey, which is the which help us to connect with connect as a, you can say, skill of the Alexa, and then it will also help to integrate our voice command, and then it will send the command to the Ddm-Iiot, and then Ddm-Iiot send the command to the node RED, and over the node RED those commands go to the MQTT platform, and over the MQTT my application receive the command, and then based on that it just convert to the action. Okay, so now I do one thing, I just jump here so you can see the views, and for that in the mobile application, if I
also
show
support
you in the mobile
HTTPS.
application, okay,
So HTTPS
in the mobile application I create something called routine. So those routines help us to take my voice command, and based on the voice command it will change the action, or it will run a flow which I developed on the voice monkey. Okay, so here in the voice monkey I created 4 flows. One is a drain tank, which is drain all the tank, then fill tank, then read the label. So it is a command to collect the data and puts the data to the HTTPS protocol, and then stop the tank. Okay, so I just go here, node RED. So if I go here, this is the HTTPS request. So when I ask him to read the label, he will read the label, and you can see that HTTPS request get enabled. So now I just run my application here. Okay, so I just on my camera so that you can also see the view from here. Okay, so I give command Alexa level up. So it's already high level, so it didn't take any command. So Alexa drain tank. So I give the drain tank command, so you can see that drainage motor started, and just level goes down. And now I just say to stop pump to run in behind. So Alexa stop pump.
Actually, I
The
do
pump
something for
stop,
my
then
kid. He comes to me, why you develop
playing,
something?
so
Okay, I give
that's why
you
this video is running. So
some
just wait.
animation for that.
So Alexa drain tank. I again give the same command to drainage enter tank.
So this
Now
is
I give a
how
command,
we can
Alexa,
create on the voice root as well, and that's all from my side about a new solution, about a visualization solution, about a edge solution, about a future ready next stage solution. Thank you very much.
Hello, hello. Once again, Shubhajit, very nice presentation about FT optics. Most important features of FT optics he has explained to all of you, and it has great utility in the manufacturing process. Once again, there is another stage of quiz. This is the 4th quiz we are going to held. The question is very easy, very easy. So let's see. Ready? You are ready? No. Gift. Okay. No. Quiz gift, please. Now you have seen all the presentations where we have mentioned Rockwell FT optics. Rockwell FT optics. What is FT optics actually? Just in one word, what is FT optics? Acha. But in one word, just tell me. You? Just in one word. What is FT? Is it a software or a hardware? It is software. What type of software? Huh? First answer, who given the first answer? You. Now anybody else? You give the answer? It is a software. It is okay. What type of software is this? HMI. Please come. Your name, please? Sanjay Das. You are the second winner. Okay, please have a great applause for him.
So actually the capability is many more. But the ultimate thing is visualize. I want to visualize the AI data, I want to visualize the report, I want to visualize the dashboard. So ultimately it's the visualizer software with all the possibilities and all the things.
Very interesting. You are very lively participating in the quiz session. Anyway, now we are going to the next hands-on from the Phoenix automation. Okay. I will request those Phoenix persons who will demonstrate the application part. Mr. Shubhajit, please come. We will show you sensor data on cloud server, reading environmental values, control devices from anywhere, isn't it? And connecting Phoenix devices with other third-party controller. So over to Mr. Shubhajit Das.
So thank you. So good afternoon, everybody. Again, we have already talked about total data module, everything. So we have a demo module here in the Phoenix product basket. So there is the inline series we have talked about, the Axeline series we have talked about. So all the models have here already power connected and data communicating through the devices from field level sensor to the IoT level. So that is a hands-on demo. We have put it here, all our modules, power supply, switches, M-guards, inline series controller, IoT gateway. So you can have a look on there. So radio line concept, where is the data transmission through wirelessly, and it is going to the cloud. We can see the dashboard, and if you changes the sensor data, directly affect in the cloud. So that is presenting our partners as a engineer team. So they will do the present and demonstrate the total data communication from field level to the IoT level. So you can start, no?
Yeah. Hi, myself Tomogno. I am from Competence Automation. Let me introduce my team first. This is Samim, and here is Sukomol, there is Sukanto. And no, actually, we need to stay here also because our system is here. So first introduction, and then yeah, come please. Please come to the class, all of you, those who are participating for the demonstration. System, come here. Come. So we are this is our team of Competence Automation. This is a system house of Phoenix Contact. So today we have seen in our pre-launch session that we have different Phoenix components. So now we will see how these Phoenix components works, how we can use this component to solve the challenges we face in day-to-day in our industry. So for that we are going to showcase few small projects that highlight the practical applications of automation and IoT in the industry. So let me.
The first experiment what you were showing,
yeah, Yeah, I'll explain. I will explain. Yeah, চলে এসেছে। turn up. ওটাকে বড় ইয়ে করে দাও। Next slide. Next slide. Next slide. So in our first project, so in few industries we have seen that we need to send the data from a very remote location to the control center, or from one remote location to another remote location. So for that case, what we use is the Phoenix radio line module. We can, if our sensor can send the data over RS-232 protocol or RS-485 protocol, then we can connect that sensor directly to that radio line module, or we can use our controller here. Here we have ILC131 controller. So ILC131 controller is connected to the radio line module, and here we use the temperature and humidity detected sensor. So the sensor is connected to our PLC, and radio line module is connected to that PLC. So this is my I can say this is my remote area. So this remote and I want to get the data, means temperature and sensor in this case, from that remote location to another remote location, or you can say here this is my control center. So from remote location to I need to get the data to my control station. So in our control station also I have the radio line module, because the one radio line module will talk with the another radio line module. So for that case, in the control center also I need another radio line module here. The range is 5 kilometers, but yes, we can also extend that if we can use the repeater.
No, I just mentioned that this same configuration.
Yeah, this same was present here.
In this box. That's why they are showing here. Okay, let's start.
This is my. Let's assume this is a remote control center. Is it visible? So here we can see this is our ILC131 PLC. This is our radio line module. This is our, for demo purpose we are using this sensor. And this is a SMPS, which is providing the power to this device. So this is in the remote location, where we can, there is no provision to line the cable or FO connection. So what we are doing is we are sending this temperature and humidity data from this remote location to the control center through this radio line module. Here we can see the data is here on the HMI. I try to increase the temperature. So you can see the live data is.
Do you see? If you could not see, please you may come over here for better visualization. লাগছে না ওটা?
না ঠিক আছে আর লাগবে না
So if you have any questions,
yeah, if I have any question regarding this, you can ask. So going to the next project. Next project.
cluster that you will see.
In industry, we have seen that few controllers are located in such a place that we cannot access that easily. It is not possible us to, if there anything happen, we need to do the troubleshooting as fast as possible, but it is not possible to access that area very easily. So for that case, we can install a WLAN device, Phoenix WLAN device to the controller, and we can access that controller remotely from the inside the factory, remotely over the wireless medium. কে দেখাও এটা কে দেখাবে Here we will see inside our kit, we have two Siemens we have two Phoenix controller and one Siemens controller. Also, we have one HMI. So, and WLAN module is connected to the switch. So, if we can connect our laptop with the WLAN, with our WLAN, then I can access all of the devices. So, I can see the program in online mode. I can do the online editing. I can troubleshoot. Even I can modify the logic, I can download everything. I do not need to go to that location. In some cases, like in overrest crane, I think that will be a good example. And in overrest crane, maybe sometimes controller is kind of placed at the top of that overrest crane. So it is not possible if there anything happen. So it is not possible to every time to take the ladder and go there and solve the problem and troubleshoot that. So for that case, this WLAN module is very suitable, and this module can work with any type of PLC. Means here Siemens is a third party, it also supports the third party PLC. Here for that case, we also use the Siemens PLC. So give us few seconds to set up this to demonstrate. HDMI কি একটাই তাহলে এটা খুলে ওটাতে লাগাতে হবে না নিই না অ্যান্টেনা ছাড়াও নিই না অ্যান্টেনা দিলে সিগন্যাল স্ট্রেংথ আরও ভালো হয় কেন connect करो online Yeah, now we can see our logic is in online mode. So here, as I told that I have different controllers here, and also WLAN module is here. So we are just access, this WLAN module is talking with that WLAN module, and we are accessing that WLAN module. So basically, we are accessing all these devices remotely. There is nothing, there is only one SMPS and on the WLAN module. We just need to power up the WLAN module, nothing else. You can consider this WLAN module is connected inside your control center, and this is your field devices, and that WLAN module is also placed on the field.
I think you go to return to the previous model. One is there, one is there. And
Yeah.
then you explain.
Actually, we have two different laptops, that's why. Yes, yes, so it's wirelessly connected. Yeah, now we are going to download the logic. I am not directly connected to this control this unit. I am connected with that unit, but I can download the controller which is placed inside here. So we are downloading the PLC program inside the PLC. Now it is in running mode. Show the logic. Yeah. So as we can see that the logic is downloaded and logic is in online mode right now. I can do the troubleshooter here. We can change anything. We can change anything. This is for troubleshooting purpose. If we face or if you want to modify your logic, this is not for control. If you want to troubleshoot if you face any problem on a controller and you cannot access that, means you cannot go there to access directly. So for that case, we can use the WLAN to access that PLC. If you can access the PLC, that means you can download, upload anything. You can do this. This is yes, yes, downloading, yes, downloading, troubleshooting, modify.
Different type of sensors and field instruments are connected with the PLC. So right now we are going to access the PLC through wireless. So this is the WLAN module. This is a Ethernet based WLAN module. What we are doing here, we just collecting the data in PLC, and after that the PLC data we are access remotely through this WLAN. This is the wireless module. This is a WLAN module. Another WLAN module is installed in that kit. So there is a 2 WLAN module we are using. Okay, so right now we are showcasing that we are going to download and upload the program, PLC program remotely. Also we can get the data from the field through PLC, because PLC actually handling lots of data. So this data is required, because in the IIoT we are talking about the data-driven IoT, data-driven manufacturing part. So this data is very much important. So how to get the data? For that we have a hardware. One is radio line, another is WLAN. So we are showcasing these 2 modules right now. this is not only for the Phoenix controller. We can use use for the any controller like Siemens, any third-party controllers. We can get the data from the other make controllers also. So I think this is the first collecting the data, sensor data. No? The next part we can continue.
This is for troubleshooting and modifying the logic, uploading the logic. That's that for that purpose. So go to the next slide. Yes. Yes. No, no, sir, actually this is not for visualization. This is not, this is for the troubleshooting, yes, for engineers. If you want to see the data inside the logic, that you can do this. You can go to the online mode, access the PLC, go to the online mode that we are showing. You can go to the online mode and you can check whether the data is coming to the inside the PLC or not. Suppose data is not showing inside on your SCADA. So SCADA is on the same network with the PLC. So first you need to check that whether the data is coming inside the PLC or not. Yeah, engineers will, industry engineers will do this. Sami, download করা হয়েছে মোবাইলে চেক করেছো এটা আসছে কিনা before exposing the link you should check mobile. Ready for the next one? Next one is huh? Okay. So going to the next project. So here we can see that how can we send the data, how we can visualize the data from anywhere in the world. So for that case, for showcasing that project, we connect one sensor, the same sensor we connect to our PLC Next series PLC. And this PLC Next PLC, as mentioned, that it is capable enough to communicate via MQTT protocol. Here we use the cloud MQTT protocol. We configure the cloud MQTT broker inside this PLC. We do not need any external gateway. This PLC can transmit the data over MQTT protocol and you can access that data from anywhere in the world. You just need to configure MQTT and you can get that. So here we use our middleware software to collect the data. So where we configured inside that software, we configured that MQTT cloud MQTT broker, and we will get the data. We will show that. Antenna is there. So okay. So for as we know that we are using cloud MQTT, that means we need to provide the internet connection to the PLC. So if it is, we can give the connection to the give internet connection to the PLC via Ethernet cable, or if Ethernet cable is not possible because my PLC is in a remote location, then we can use the GSM modem. Here also we use one GSM modem. We use Airtel SIM here. Inside the GSM module we have Airtel SIM, and that GSM module is providing internet connection to the PLC. Now the PLC will send the data to our middleware software through MQTT. ও আচ্ছা ওটা উপরে চলে গেছে না হ্যাঁ তুমি মাউসটা নিয়ে যাও উপরে মাউসটা আরও নিয়ে যাও মাউসটা আরও নিয়ে যাও এইখানে নিয়ে ডাবল ক্লিক আর একটু উপরে হ্যাঁ আর একটু সাইডে করো duplicate kar do. Here you can see we create a dashboard here. We use here Node-RED to get the data inside the to get the data from that PLC to our Node-RED, and we create the dashboard here also. So here we are going to change. Yes, we are going to change. We are going to change the data. Don't change. We are going to change the data, and you can see that the live data is coming here. You can see the value changes.
If you have a mobile, you can use this from mobile. If you have a laptop, you can open the laptop also. Or any browser.
Yes, on your mobile phone you can feel free to type this URL and you can check this data. So for demo purpose, we have created this. This can be customizable. Sorry? Sorry? This site can't reach it.
Anybody else got the screen in your mobile?
At first you have to connect the net.
Excellent. Let me check whether the URL is working or not. Slads dashboard. देखो तो हम दर Yes, see the URL is working. The report.com. Is it visible on your mobile? Is it visible on your mobile? Oh, network issue. Okay. See, that guy has seen that. Shift, we can also send the data to the managers automatically. Daily consumption. Now this is our daily consumption dashboard. You need to select the date, then the select section, in which section data we want to see. Okay. Then fetch the data. Here we can see the daily consumption of these two area, these two sections. That is the opening KWH. This is the closing KWH. Means when this is our consumption KWH. Please add one. Yes. So I can add another. Means we can add the different sections here. And all these these are demo data. That's why these data are very much close to each other. That's why it looks like equal. So if we can change this data when we will get the actual field data, it will not look like this. Next slide. This is the load profile dashboard. This basically shows the hour 24 hours load calculation hourly. The zero hour means the first hour how much load was there. After 1 hour how much load was there. After 1 hour means on the third hour how much load was there. So we can get the 24 hours load consumption details here. This is another dashboard of the EMS. This is another maximum demand dashboard. This also analyze this is also analyzed report of the energy monitoring system.
This is the maximum demand dashboard. All the plant have contract demand, that is apparent power, like 500 kVA or something like that. So if you exceed or overshoot the contract demand, you have to penalty from the government or electricity board. So in this scenario, we can do one thing, that is alarm. If the maximum contract demand is overshoot, if I alarm set in 80% or 90%, you can give alarm or some notification, so you get that WhatsApp or email, something like that.
Okay, next slide. Till now, we have seen the visualization only. We have seen we are getting the data from the PLC or from the sensors, and we are just visualizing the data. Now, here we are also visualizing data remotely from anywhere. Now we can see that how we can control the machine, how we can control any machines remotely from anywhere using the dashboard. Next slide. For that, we have one small old VFD here, and we connect that VFD over RS485 communication with the ILC PLC, and we will control that VFD. Means we will give the frequency command to the VFD, and we will start and stop command to the to the VFD, and we will see that the running frequency and also whether it is on or not, we will see. Basically, we will control from the remote station. Stop. Stop. Yes, VFD is running at 50, 40. See, now VFD is stopped. Actually, the VFD was running. That's why it was showing. Start the VFD. First give a frequency command. Do it from HMI so that they can see. Do it from the HMI. Not here. Here we are setting the frequency command.
You can start direct from HMI.
Stop. Yes. Now you can. Now my VFD is started, and so you can see the live data is coming from my VFD, and you can access this from anywhere. So as for the animation purpose, we use this bearing logo. As the frequency increases, this also the speed of this bearing also increases to show the RPM of the VFD. Sorry, for the motor. Are you giving command from the mobile phone? Yes. I will request that when we are giving command from one mobile, please don't send the command from the another mobile, because it will take the two commands. Yes, she is doing from there. She's just sending the frequency command from the mobile. Yes, I think you decrease. Yes, yes, there is decreasing.
You can increase to some extent, and let's see once again.
Actually, the VFD is communicating in via RS485, and it's a pretty old protocol, and the VFD also, we cannot provide three-phase supply here. That's why we use the single-phase VFD. It's pretty old. That's why it takes some time. Otherwise, you can see the instant effects. Car Wi-Fi. No, it's not off. It's increasing.
That's why it is hands-on. Today our target is to execute the program in the last phase hands-on. So this is a part of the hands-on that you are doing right now. Maybe most of the mobiles, the connectivity problems, you are not getting this thing, but you must get it, and you can remotely control
The students are not interested at all. না ওগুলো ঘেটে দেবে। রেকর্ডিং এর কিছু একটা রেকর্ডিং Can you continue? Next slide. না ও ঠিক আছে ওটা okay. Now in industry means there will be machines. So and for machines, our main target was to get the maximum output from that machine. To get the maximum output from the machine, we need to check the availability. We need to check the performance of that machine. For that, we use OEE dashboard, overall equipment effectiveness dashboard here. So we have one OEE dashboard. So in this case, sorry, please go to the slide. Here, inside the industry, there will be different make PLCs are there. Here we show that the one PLC, that is Siemens PLC S7-1200, and one ILC 131 PLC from Phoenix. So we have multiple machines, and different machines use the different PLCs. So we are collecting the data from the different PLC, and we create the OEE dashboard. Yes. Yes, this is our OEE dashboard. I think it is not exactly, the resolution is very bad. So this is the main data entry point here. Here we need to select the date here. First the date, enter the date. Yes, we enter Then in industry, we know that there will be a shifting duty because plants cannot stop. So in industry, we have the different shifts. Here we have A, B, C, 3 shifts there. Each shift maybe 8-hour shift. So we choose the shift A, and then we need to set the production time. So how much time I want to run the machine. Say if my shift is 8-hour shift, that means suppose I need to run the machine for the 6 hours. So the 360. Oh, it is in minutes here, right? Minutes. So for example, I set 360 here, 360 minutes. Then I need to set the planned tonnage, means how much production I need for today. So these two data should be filled up by the higher authority of the plant. So they before starting the session, starting the shift, they can set these data, that how much production I want for today and how many hours I need to run the machine. So that person also, as our dashboard is exposed, it can be accessible from anywhere. So that person, that higher authority person, do not need to come to the field and enter that inside the HMI. He can do this from his mobile, or he can do this from his laptop. He can set this data at the starting of the shift, and after completion of the shift, they can see that whether the machine performs for that selected hours or not, whether the machine produced that planned production ton or not. If there is, if the machine does not run for that particular hours, then what happened? What was the factor for that the machine did not run? If there is, whether the machine was not available or not. If the machine was not available, if there was a downtime, then what type of downtime was there? We have a detailed analysis report of that. And also we can send the data after send the report after completion of the shift to the manager. Yeah, here we can see the live data. These are the once the shift before starting the shift, it should be 0. So once the shift started, we can see the live data. Here, for example, we use one machine called extruder. So first one is extruder total runtime. Okay, so when we will send this production time and production ton, then we need to click this send to production button, so that it will directly go to the PLC, and it will also reflect on the HMI, because operator should also see what was the today's that shift's production time and also production target. So we can also see. Yes, it is also visible here. If you can see, this is also visible here. So operator can see that that shift's production time and also machine running time and also the production target. Okay, now go to the manager can also. After completion of the shift, the manager can also select the date and the shift and then fetch the data, so that he can see the detailed report of that machine. Yes, here you can see the data. The date of the data is yes. We select 26 and shift A. Then fetch the data, then we get the OE report here. So in this report, we can see as in the first column, this is the machine name, then it's the which shift it is, then date, then the parameters, then value and units. So in parameters also, if we have seen these first two things we set at the first, that is planned production time and planned production ton. Then the runtime of the machine, how many minutes the machine run. Then if there is a downtime or not. If there is a downtime, then how many minutes downtime was there? This is 36 minutes here. Whether there was a no load time or not, whether the machine was running on the ideal condition. Because if my machine is running on the no load or ideal condition, that means there is no means of that, because we are just consuming electricity only. There was no production, but we are consuming electricity. So that is lost for the plant. Then whether there was a power failure or not. If there was a power failure, then what was the duration? Whether the machine was jammed or not, means whether the machine was taking, means we are giving command to the machine and the machine is taking high ampere, so we can detect that whether there was jam on the machine or not. So that time is also calculated here. So this was the actual output. And we know this is our 60 ton was our planned, but here in this case I can see my actual output is 48.6. That means it is less. So why it is less? Because there was a downtime, there was a power failure, there was inside the downtime these factors comes. There was a power failure, machine jam, there was no load run. So depending on this, we calculate the three main factors of OE: percentage, performance, and quality. And this is at the last we have shown the OE percentage here. And this is our downtime analysis report, that if there was a downtime of how many minutes here? See, you can see the 6 minutes downtime was there. So what type of downtime was there? There was a power failure for 10 minutes, there was a machine jam for 14 minutes, and no load run for 12 minutes. And also we can see this graphical presentation here, and through which we can also analyze the factor. And this is fully customizable. Again, I'm saying it is not like that this dashboard can be like this. It means we can add the different types of parameters. We can change the color theme, visualization effect, means the visualization chart. It is not like that it has only bar graph and pie chart. It also have different types of charts. Other donut charts is also available. So different types of charts is also available. This is also means we can also create user account here, so that no one can access this. Only few users can access this. We can also do this function that user can access particular pages, not all pages, like SCADA. We can also do this here. And also using API, we have also already implemented that. We using API call also, we can take the data from SAP or also send the data to the SAP, because SAP is a very common platform which is used inside a plant. So we can, this is also supported. Yeah, now we will generate the data. We here, for example, we create the download the data means report in form of CSV format, but we can generate the data in PDF format also. Also, we can send the mail. We can. So download the report. Yes, we have downloaded the report. network connection issue. আগে সার্ভিস শুরু করে দেবো কন্ট্রোল সিমের আবার কন্ট্রোল সিমের
না না কেউ নাই ভিডিও ইমেল হবে স্যার ড্যাশবোর্ডটা বলো ড্যাশবোর্ড ওইখান থেকে খুলে Thank you. That was our last slide. It was the last project. Yes, we have completed. That was the last slide.
Thank you, Phoenix team, for the nice presentation of live data available in the mobile, internet connectivity, and how actual IoT can be implemented through Phoenix Contact and Phoenix PLCs. And we have seen many ways how it can be done and how we can design a dashboard and how we can control the data from the mobile phone and from laptop or from anywhere, any location, anywhere in the globe. So thank you once again, Phoenix team, for their nice presentation. Our the last presentation for today's event is digital twin, and Mr. Shubhajit Bodhok will present that slides. And finally, over to Shubhajit, please. কি বলছেন এই ওইটা কি বলছেন এই সাউন্ডের এটা জ্যাকটা কোথায় সাউন্ডের জ্যাকটা দেখো তো
I hope I am audible now. Okay, so everyone sleepy, huh? And I think I am the culprit actually to hold everyone on the last session. Okay, no problem. Please excuse me. Okay, So now I am saying about a topic named digital twin to evolve your designing and commissioning time uh, and give your plant a capability for the next level. So what is digital twin? Can anyone say from the team? Anyone from students? Do you know about digital twin? What is digital twin? Anyone? Students, please. Okay, say me about what is twin. Clone. Anyone from student? Twin. Double. What is double? Twins mean same looks, same behaviors. Yeah, twins is there. Please come this side. Arre, come on the stage, my dear. Please come. Yeah. I request you, please come on the stage. So we have physical twin. We have physical twin here. Now I am saying what is digital twin. So difference between the physical twin and digital twin is something like that we have two same identical physical machines. Sorry, please don't mind. Physical two machines are here. But if he acts something, the other maybe differ, okay. But in case of digital twin, if you act something, it's act same like you. Like when you develop a robotics application, just you in front of the robot, that is a next generation. So you just movement like that, the robot also movement like that. So, but instead of the motor, if there is a digital or virtual things are there, and it can replicate every activities on you. And after that, we can train the model like that this attitude is the same for the physical device and that virtual device. Instead of presence of the physical device, we can interact with the virtual device to change everything. It's mean, if I want to simulate, just hit him. Then I don't hit that person, I hit the virtual model and it will act like, something like that. Okay, just like you can say if you go to any shopping mall, there is a game parlor there and you just kick a ball and it feels like in the virtually that ball go to the goal. The same things we done in a digital twin. Thank you. So how it help us for the industry level? So in the industry level, we know that we are planning for the commissioning. So when we do the commissioning, actually, we have a planning for the designing, we have the planning for the manufacturing, also we have a planning for the commissioning. But in actual, the time or the things never meet. Why? Because there are some problems are there, some legacy systems over there, we have some communication with the OEMs, and that is why it will take too much time to develop those things, and during the commissioning, we do the control testing. So control testing means I just integrate my automation system with the actual system. Without develop the machine, I can't do the control testings. And that is why during control testing, the time take a little bit high. And that is why we never meet our deadline. So when we are saying about the digital twin solution for the Rockwell automation, we give you a platform called virtual commissioning, which help us to develop a virtual machine for you before the machine comes in the production line. So if I have the virtual machines like that person, so I can interact with him, and if I feel that there are some debugging is there, I can debug those things before it manufactured. Also, I start the control testing during the manufacturing, not during the commissioning. It means I can interact with the emulate or simulate controller over there, and also I can emulate the inputs. It means I can create all the mechanical features in between that virtual model. So that virtual model help us, if I give any output from the PLC, it can sense the output, and based on the mechanical things like what is the speed of a VFD motor. Normally when we do the simulation, we give a 50 hertz speed for a particular motor, and we consider that as the input or the run feedback. But in the virtual twin, it will consider all the mechanical aspects, and based on that, it will give you what is the frequency, what type of frictions are there, what are the environment conditions are there. Based on that, it can give you the real input, so that we can easily simulate those things and interact with the machine for the actual one, fill the actual one data, so that I can get a fine-tuning data. And if I receive the fine-tuning data, it can help me to reduce the commissioning time. So automatically, my commissioning time become very less. Not only that, if I have the virtual model, after the commissioning also operator testing, operator training is very much required. So we can start the operator training with that virtual model, maybe wearing a HoloLens or the VR goggles or something like that, and he feels that he is in the field. And so that he can also make his competency, high competency, before the machine is manufactured. So what is the challenge? So normally, when we developed any solution or when we developed any machines, we know about the machines. Okay, so we have the idea, we have developed the same types of machine from 100 years or from 50 years. But I don't know about the environmental condition of that particular location. I don't know about the, where is the beam, where is the location, maybe that is in the hill station, maybe that is in the sea level. So I don't know about that. So when I give any data for the purchase or for the proposal or something like that, I give the data on my knowledge base, not in the actual base. So it is not tested data. So that is why after develop everything, when the commissioning is happened, we can check that sometimes the panel size is not proper, sometimes some machines debugging is required during the development, some designing debugging is requirement. So those things affect the entire commissioning time of the project. So when we are saying about a digital twin on an industrial specific, so it can accelerate the project development so that you can develop the project with the testing data or simulated data. Second, train operators safety and everything before the machine is produced. And third, communicate the solution effectively and remotely. So remotely, you can use your remote controller. So we have some simulation controller of PLC, simulation controller of DCS, distributed control system, which interact the virtual model instead of the actual model and can give you all the output, all the input, all types of attitude which can easily help you to fine-tuning your system. So like this model. So you can see that I have created a virtual model of a bottle filling line, okay? So this is the actual model. So instead of interact with the actual model, I can interact with that. If the line length, the conveyor length is 3 meters, I can create it 5 meters or 6 meters and then interact with that with all the possibilities, all the learning data. I can interact with that and it can give me the output. If instead of 3 meter, if it is 6 meter, what will be the output? What is the ROI? So we can easily identify those things. Also, some implemental jobs or Kaizen activities happen on different plants. So for the Kaizen activities, we have a limited budget. But the thing is, if for the Kaizen activity, I need a operation downtime more than 10 hours, 11 hours, no plant give you the time. Because operation time is more impactful. It means that price is more impactful. So if they have the virtual solution or the virtual twin solution or digital twin solution, they can create the fine-tuning data. Then automatically the shutdown time or downtime, it's become 1 hour or 2 hours instead of 12 hours or 13 hours. We can give the time to the Kaizen team or the operator team or the maintenance team so they can easily do that. Also, we can create, so before few sessions, Devashish says about that we have our Encompass partner is NVIDIA. So NVIDIA Omniverse, with the NVIDIA Omniverse, we can create a virtual plant. So when someone from the HO or some person comes to your plant to visit your plant, instead of go to the actual plant, you can show them entire plant on the virtual area or the virtual reality, okay? So he can wear the goggles and he can feel all the plants, where the machine is installed, how it will work, how it is happened. So he can also ask, if I make the speed little bit high, what will happen? We can easily interact with them with the virtual machines. So this platform actually, it is the actual Rockwell production unit in Singapore, which we have developed on the digital twin model. So how digital twin help us in different scenario of your project, our project life cycle? So first is process modeling analysis. So process modeling analysis, if I'm planning to any project, I am planning this project, after a year I need a production. So for that, we have a different software. So not only Emulate 3D, we have a software called Arena. So Arena gives you the process simulation scenario. So using the Arena simulation, you can easily understand after 2 years or after 1 year what will be my production. So based on that, you can debug your entire line, you can add new machines, you can remove one machine, which is not required actually. Second, for the demonstration purpose. So when a OEM comes to you and said that in this area, I just developed a machine for you, but instead of that, if you show virtual machines on that area and how it will work like, and what type of workforce you require to run this plant, it can very much easy. Next, system design. For the system design purpose, when I have an entire virtual model and I have interact with that model instead of my knowledge, so I have got the data. It's mean what data? That is the testing data. And based on the testing data, I can help system design to evolve the system design and do the system design very easily. Next, virtual commissioning. So virtual commissioning help us without interacting with the actual system. We can interact with the virtual model and do all types of control testing over there. So I can do the control debugging. Next, operator training. So if I have the model, before manufacturing the unit, we can train the operator that what SCADA switch you must operate, what HMI switch you must operate, how we will interact with the systems. But the system is still not available, so that they can also understand that what system is going to come. So they are very much in very good condition to accept the new machines on their systems. And last, continuous improvement, like Kaizen activities or the implemental jobs. So instead of going too much presentation or everything, I just show you what type of use case we have developed. This is a smarter proposal. So smarter proposal means I have multiple robots in my plant. So with the multiple robots, how the production work. So if I plan for some new project, I can do the virtual commissioning. We have the library, we can add those robots over there. So we have the ABB robots, Kafka robots. So all types of robots, KUKA systems robots. So we can use the library to install those robots over there. Using the robot simulation software, we can integrate with that, and after that we can run the model and I can check after 1 year, after 2 years, what will be my production. So based on that, I can take the decision. So it is a smart proposal which can helps you to identify what is the actual data after commissioning done. Next, what I say about the Arena software. So we have provide this solution to one of the tire manufacturing industries. So here we have different modules. So based on that modules, also in the 3D simulation, we can develop something in the Arena which can give you an entire picture that after this system implementation, what will be the process output and what will be the production output after a time. Here's something called a virtual showroom. So in your area, after the machine comes, what it looks like of that machine. So when a vendor comes to you and say, this type of machines comes to your system, here is the, you can say cylinder, here is the motor, it is operated like that, how many workforce is required to run the machines. It is very easy to identify that what is going to come in my system or what is going to come in my plant. Next, it is a simulation model. So simulation model help us. Just here I can show you that painting line of a automobile sector. So how it looks like that when the conveyor pass the, it's mean the car. So from here you can easily identify the safety barrication and the parameters you have to maintain, how many conveyors you require. Because sometimes what happens when the persons comes and consultants also there, in front of the consultants he says, I need 5 motors for that or 5 drives for that. Why you require 5 drives? Instead of showing that 5 drives is required, you can show the entire plant and you can say, here you need a drive for this conveyor, there you need a drive, and those need to be synchronized with each other. Then you can create this type of digital twin model to understand the things. Next, how can I get the data? It's mean, here we have a plan for a warehouse. So I just create a virtual model of a warehouse, then I run in the full speed. So 1 year means only 1 hour. So in that 1 hour, I can access that how many material I can store there, how many material I can export and import using this warehouse. So I can easily understand, I can create trends, so it can easily interact with the your analysis data, also the CSV data or Excel sheet. So you can get all the data, then you can go to your higher authority and ask for the budget for this project. Not only that, if I have planned for a safety barrier where my seal 2 PLC is required, where my safety module is required, so in that case I can easily create those types of barrication and those types of safety portfolio over there, so it can easily integrate with your safety PLC also. So our latest or our new emulator software also support the safety PLC. So using that you can also think about that this safety barrication is required or not, and you can design your system based on that. Now I just jump to the virtual commissioning, which is the best part of the digital twin solution of Rockwell Automation. So this is how we design a project, okay? So we have a plan for designing, manufacturing and commissioning. In between the commissioning, the control testing start, and this is my deadline for the project. And a project means a time. But actually what happened? Designing time take little bit high, manufacturing time also take little bit high, automatically commissioning time become increased, and control testing also become increased. We don't meet the deadline, and it will affect the project. When we are using the virtual commissioning of digital twin, so in that case, we are not able to compromise with the designing time because it is not in my hand. For the manufacturing, we are dependent on the OEM, so it is also not in my hand. But before the commissioning start, I can start the control testing, not only control testing, also operator training, so I can meet my deadline. So this is the funda. So some use cases are there, I want to show you. So how it will work? So you can see in the right side, there is my digital twin model, and this is the actual model. So instead of collecting data from the actual model, I use E3D PLC connector or Emulate 3D PLC connector. So in this Emulate 3D PLC connector, we can get either actual controller if I have a spare controller, or we have the emulate controller, I can use that as a processor. For the emulated input means I am taking the input from this virtual model instead of there, and I send the output to the virtual model instead of sending those data to the actual or physical data. So based on that, I can collect all the data, I can fine tune those data, and after that, I can verify the data, will it work or not, and after that, I can change the parameters on the robot, and then I can apply the things in the actual machines. So automatically, it will reduce my entire downtime, entire shutdown time if I need any implemental jobs. So we have a very good use case, okay, what we have done during the COVID situation. So this is something, it is for the US-based aluminum industries. During COVID situation, we sent some conveyors there. So there is one stacking unit is there, dual turntable is there, and it carry the long billet. So you know about the billet, so aluminum billet. So before the billet passing on the conveyor, there is a saw cutting machine, which cut the billet in small pieces. But due to some logistic issues, we are not able to transfer that cutting machines. But the customer wants to run the plant. So they ask us that if I don't use the cutting machine, your conveyor is well enough to carry the heavy load, your dual turntable is well enough to carry the heavy load, is it possible or not? But we don't have the machines, that machine is already dispatched to the customer place. So in that time, we do one thing, we don't have the controller or control panel, we replace our control panel to our emulator solution, is mean the Logix Eco, which is our emulated PLC, and we just use the virtual model for the actual feelings. So what will happen? So this is the actual machines where the saw cutting systems is there, and it will send a small loads on the conveyor. And after pass the load, the stacking can pull the material from the conveyor and then just put it in the dual turntable, then dual turntable rotate, then the strapping happened and it is going for the dispatch. So we must consider without these saw cutting machines. So what we did, just a minute. So we created a digital twin solution without cutting the machines. We considered the full load, and after that we using the same SCADA, and then we set some parameters on the stacking crane for the ZIG units, and also some we set the, it's mean the stretch of the individual part of the dual turntable, how much it will extend, and after that we run the system with the fine tuning, and we fine tune all the parameters of the logic platform and the SCADA platform. So it will take little bit time, but we also have a tracking logic inside the SCADA. So from there we can also understand that how much production will done in every shift. So we send the data to the customer and ask them, this much things we can done with the existing system, and we can share you the fine-tuning logic and fine-tuning SCADA so that you can just use that and you can get that output. Is it okay for you? They say, yes, it is okay for me. For your information, normally if that OEM go for the commissioning, it will take not less than 35 days. But the customer itself commissioning the entire thing within 25 days. So based on that, the customer now asks us for the every machines to that OEM that we need every machines after virtual commissioning. So we want to reduce our commissioning time. So for whatever new project comes, we need these things, not only the external customer. For your information, Mahindra Automobile now asks to all the OEMs that they need the virtual commissionings before any machines they need to be purchased. So for your information, we have our own digital RCSI or Rockwell Certified System Integrator who can develop the SolidWorks files or 3D files in a Creo or SolidWorks, then create the entire virtual machines for your plant. And also you can consider this as a service, not a solution. So as a subscription base, you can take that model from them. Now the operator training part. So this is something operator training. He just wear the VR goggles and then they can feel that they are working with the actual system or actual machines, and after that he can revolve their competency, he can learn everything without interacting with the actual machines. So this is not only for here, for some mines in the Hindalco, also they are considering these types of solutions, because in the mines you don't need to go to the mines inside, you can train your operator or train the new GETs using the 3D model. When we are saying about the plant scenario, so we have a teach points, so we create an entire 3D model of a plant, and multiple persons can wear the VR goggles and they can feel they inside the plant shop floor, and they can interact with us, with each other, and they can learn the entire machine, entire system before it's happened on their plant. Now, a new thing. So we know about factory talk optics. So I just say, if the software, the Emulate 3D software with the Omniverse, the cost is very high, and the size is very high. So how I can install that system in my soft flow? So in that case, what we can do, we can install the entire system in our local cloud or our local server. It's mean the central control room or central server. After that, we can provide the entire web applications of that Emulate 3D to the plant level. And optics support MQTT. So over the MQTT, the operator can send the parameters, send the data directly to the cloud. And based on that data, Factory Talk Optics also helps to convert the data, the MQTT data, to OPC UA and set to the Emulate 3D model. Then he can see the view that after change some parameter, what will happen. So he can develop the entire application in his HMI instead of the high-level machines. So how many times through the Factory Talk remote access he can access, that how many times the operator access the entire system. So for that, based on that, he can charge to you. That this much time I have used your virtual platform, so I charge for 3 hours or 2 hours. You can create those platforms. So here we have a use case, what we have developed. So we test one machine in the Gurgaon and one machine in the Kolkata. So From the Kolkata, we shared that from the Gurgaon there is a machines, and over the MQTT I have the 3D model in Kolkata. So I share all the 3D view and everything on the machine, and from there he just operate using the actual machine system and check parameters, and after that he change the data. So how it looks like? So this is the actual machine, this is the Gurgaon-based system, and here it is in Kolkata, in the remote. So whatever value he just provide, I receive the data on the factory talk optics, and over the OPC UA I send the data to my model. And he can view what is the output. So based on that, he can change the parameter of that particular machine. So any questions? Students are smiling, but no questions. So this is digital twin model at cloud in Kolkata. The SCADA also in Kolkata, which helps to convert the MQTT data to OPC UA. And the physical system is in Gurugram, and the physical device also is in Gurugram. So where he wants to change the value. So he can check the value and he can change the value. So also in the optics, you can access the 3D model, okay? So if the 3D model already available in your plant, any central server, from there you can also access the model in your plant soft floor. And after that you can change the parameter, change the data easily over there. Like this. So this is the optics platform where I pull the data as a web cloud and I can interact with that. So if I say about our digital twin case, for the sales and proposal, we use Arena. Also, we use Emulate 3D for the sales and proposal. For the designing and prototyping, test and deployment, operational and maintenance, we continuously using our Emulate 3D software. And we have a Studio 5000 logic software with the Logix Eco, the emulated controller, which help us to connect with the controller with the actual, instead of the actual machine, to the virtual systems. So this is the all portfolio of the Factory Talk Twin Studio. Presently it is not available. This is our cloud-based solution where same like on the Factory Talk Optics platform we provide this service, but presently it is not available. Presently we provide only through our digital system integrator who provide you this service. So that's all. So we are taking your manufacturing to the next level. So please help us, connect with us, and we can help you. Thank you.
Very good afternoon, everybody. This presentation was the last and final presentation. And the entire session starting from the mornings, it is end today. But before the end, we have a vote of thanks. I would request our MD for the vote of thanks. I would request our marketing manager, Mr. Ravi Kumar, please come for the vote of thanks. Over to Mr. Ravi Kumar.
Thank you. So we are ending this session. So before ending, I want to tell something. I think we all have a WhatsApp group for this. So after that, we have, I think, 5 virtual classes are there. So I will tell them all to attend that. So after that, there will be a evaluation session also, in which there will be a testing, something like that. There, from where there also we will be actually selecting first 3, and we will be going to the companies, to their respective your companies, to give the facilitation. So thank you very much. Thanks.
So thank you very much for your kind attention. And you have everybody. you are so seriously and with your dedication, and you have come, you have crossed long distances and come here. I once again thank you for your participation. We have a long plan in future to organize this type of events with new and new technologies. So thank you. The session is end. Okay.